Good morning and thank you for joining us for the British Amateur Television Club CAT24 Convention Part 2. I'm David G70RP and together with my wife Tammy M0TC, who is sound and vision mixing, we're very pleased to again help the club produce CAT24 today, which is being broadcast live to both BATC Streamer and the BATC YouTube channel. Our chairman is Martin G4FKK, and as well as a long career in professional broadcasting, he's been active in amateur television since the 1970s, and as well as operating, enjoys making his own ATV equipment. So now over to Martin, who will formally open CAT24 and give you an update on the British Amateur Television Club.
Thank you, David, and thank you, Tammy, for doing all the vision mixing as well. And welcome to the BATC's CAT24 Part 2, the online version. Evidently, we have about 100 viewers already on the various streams. We're also, Mike G0MJW is in QSO on QO100, and the CAT24 is going out there as well. So, I'm very grateful to David and Tammy, who've once again given up their time to organise the production and streaming facilities on this CAT24. In terms of the programme, unfortunately, we've had to make a few changes to the schedule of presentations. As Tom ZR6TG, who was scheduled to be our after lunch speaker, has unfortunately had to pull out at the very last minute. He had some last minute family and work commitments. He was working till well past midnight last night. He's very apologetic, and he says he'll make it up to us, so we can look forward to something from Tom in the coming weeks, I hope, and I'll make sure everyone gets to see or hear about that. In the meantime, Martin G8KOE has very kindly stepped in right at the last minute to discuss Allstar, which I know some of you have seen us discussing on QO100, and it sounds a bit internety, but actually it's proved to be a very good back channel and coordination system. But Martin will explain that all during the lunch period between 12 and 1 o'clock this afternoon. In terms of the club, the first thing to say is that our finances are nice and stable, despite the hefty bill we had to pay for the Serret tuners, which we had specially made and supplied by Serret, so that we can continue to make mini tuners, etc. And thanks to Dave G8GKQ, who's our noble treasurer, who's keeping all that ticking over, as it were. It's been a very busy year for the club. We've done a number of rallies and events across the country, supported those, and again, organising the supply of valuable components that are difficult to get from anywhere else. We've been getting our European warehouse set up for the shop so that we can get some more prompt and economic delivery of stuff from our shop to our European members. And I'd like to thank Noel G8GTZ and Benno PA3FBX for organising that, shouldering the burden of making sure people get their orders promptly and for a reasonable postage price as well. In terms of projects, I suppose Pico Tune has been the biggest breakthrough. Obviously, because we had to have the Serret tuners specially made on commission, it made them slightly more expensive than they had been hitherto when they were in general supply. So Colin G4EML and Brian and various people have got together to make Pico tunes. So that's now, it sort of levels out the price a bit for making a mini tuner or a Winter Hill, which are still staple methods of receiving DATV at the moment. Sorry about the umming, by the way. I was talking to Martin earlier, and I do a lot of this. We had CAT24 Part 1 back in August, and that also involved our general meeting, and in terms of our committee of 10, we had 2 of our long-standing committee members standing down. That was Rob, G8NXG, and Tim, G4WIM. And I'd like to thank them for their sterling service over the years. Luckily, Gareth, G4XAT, who got nominated to join the committee, agreed, didn't turn us down. So he's now a full member of the committee, and we're looking forward to working with Gareth. One of the sadder things for perhaps on the committee meeting at CAT24, at the general meeting, was that the following committee meeting, we decided that as the subscriptions to the club hadn't changed for many years, and everything else is going up, so we've had to reluctantly raise our subscriptions very slightly, and that'll commence on the 1st of January next year. So apologies for that, but you know what economics are like. Also at the committee meeting, we were very pleased to offer Brian, G8GQS, honorary membership. He's been a very long-standing member of BATC and was our treasurer for a long time. Kept the books in good order and was able to hand them over to Dave very successfully. Club membership remains strong. We've got just over 1,400 members, which is about the same as last year. Some people have left and not rejoined, but we've had new members joining as well. So if you haven't rejoined and you're watching this and you've just forgotten, you may as well rejoin, as it were. Before January the 1st would be a good idea. Sorry, Dave, the treasurer. A bit less money coming in there. The programme of events will be shown on the screen throughout the presentations this morning and this afternoon. We're hoping to finish by 3 o'clock. It may be before, maybe after. So the programme has had to shift a bit. If you've got any questions for today's speakers, you can post those on the BATC streamer, on the chat there, and also on YouTube. So on the chat facilities on YouTube. So do that. Try and keep sort of general chit chat down to a minimum so that David has a chance to see the questions, moderate them, and then put them to the speakers. So that'd be good. So CQTV, by the way, if you've got any articles you'd like CQTV to feature, then do put your writing talents to that effect. Right, well, I've been droning on far too much, so let's get on with the show. I'll put it back to David, G7URP. Thanks, David, for organising all this, and leave you to run the meeting in your usual inimitable style.
Thank you very much. Hope that's good. Thanks very much, Martin. By the way, we've got 136 now watching on YouTube and BATC, and of course loads more on QO100 as well. So really good to see everybody here. Now I'm pleased to introduce our first presenter, Dave, G8GQK. Sorry. Of course, Dave is no stranger to BATC, having done most of the jobs in running the club as far as I can see, and is currently the treasurer. He's here today to talk about developments in the popular Portsdown DATV transceiver, and I'm pleased to let you know that you can ask questions or make comments using either BATC messaging or YouTube chat during Dave's talk, and I'll be able to read as many of these as I can to him after the presentation. Please include your first name and call sign if you have one within every message. But now over to Dave. Welcome to CAT24, Dave.
Thanks very much, David, and thanks to you and Tammy for all your hard work in setting it all up. Good morning to everybody. I'm going to talk about Portsdown in slightly different terms this morning. Normally at CATS, I concentrate on the ATV aspects of Portsdown, but I want to talk about the test equipment aspects. But you're not going to get away that easily. So let's have a look at where the ATV aspects have gone and some new features that have appeared first. Going to look at the Portsdown 5, look at the updates, and then the test equipment, and quick word on web control as well. Now, the Raspberry Pi 5 came out a year ago, and everybody said, what are you going to do about Portsdown 5? And I said, hang on a minute, I need to evaluate whether it's worth it. I do think it's worth it. It's going to be an incremental improvement And what I'm aiming at is the classic 7-inch touchscreen, so you can swap out a 4 or a 3, a Raspberry Pi 4 or a 3, and upgrade to a Raspberry Pi 5 in there. It will also work with an HDMI display and a mouse, so you don't need the classic touchscreen anymore. You can just use an HDMI display to control it, or you can display it from a web browser. Now, I do hope to migrate most of the Portsdown 4 features and put in a few new ones to take advantage of the Raspberry Pi 5 capabilities. But Portsdown 5 will work on a Raspberry Pi 4 as well. So there will be some backward compatibility. Lots of work to do. I'm hoping for a release sometime about the middle of next year. The menu will be slightly more complicated as shown there, another row of buttons just for a bit more flexibility. So what I've been doing for Portsdown 4? Well, I've added web control that is fully implemented on the 5, but it's also on the 4 now. Put a mute button in the receiver, looked at system time and some network utilities, and made some more support for Pluto. Web control. This means that you can use all the features of a Portsdown 4 from your browser or your smartphone. So when you're out in the garden, you want to see what spectrum is on the a band viewer of Portsdown. Point your smartphone at the IP address of your Portsdown, and you can see the spectrum from your smartphone as long as you're on your home LAN. So there you see it in Chrome. Receiver mute button. Gareth requested this feature, and I think it's really valuable. Some people may not realize when you actually click receive on a Portsdown, the touchscreen actually has a number of functions. Top left actually restarts VLC in case the picture is frozen for some reason. Middle left brings up the parameters, MER and so on again. Bottom left captures a snap. Top right increases the volume. Bottom right decreases it. And then if you tap in the middle, you can mute and unmute if you need to. So that's the touch overlay that's in receive. Clearly, I can't show the touch overlay while the picture's up there. Another feature requested by Gareth was system time. When out portable, if you need to capture snaps and know what time you captured them at, you can enable this from menu 3, and it puts the time and the date at the bottom left of the received snap. To enable you to check that function, system time is also shown on the info screen on menu 2. You do need to fit a real-time clock for this to work when you're out portable. One utility that I use a lot, maybe other people won't find it quite as useful, but it depends on how many Raspberry Pis you've got on your network. If you want to know what IP address a Raspberry Pi is that you've just connected to your network, from menu to the file menu, there is list network devices and list Raspberry Pis. List network devices lists everything on your network. Now, on my home network, that's about 30 odd devices, which is tricky. So I've filtered it. So on the other button, you can just see the Raspberry Pis. And the entries you get on there are the address of the Raspberry Pi you're looking at, the address of the Pluto interface, if you've got a Pluto connected, the address of the Pluto itself, and the address of any other Raspberry Pis on the network. And there you can see 2.158. That's my Portsdown 2020 that I use for the QR100 net. The noise figure meter and the noise meter both only used to work with the Lime SDR. They now work with the Pluto as well. Same functionality, just different SDR. A new feature that is coming soon. So, Brian G4EWJ has taken the chip that is used in the Caribou Light SDR. That hasn't been the most successful in the world, it must be said, but he's taken that chip and put it on a PCB to make it transmit TV at 437 2.4 gigs and 3.4 gigs, the frequency bands are limited by the chip. It'll do anything from SR 100 to 1000 with QPSK and 100 to 500 with 8 PSK. We've interfaced it with the standard Portsdown 4 build, so this will be coming to Portsdown 4 and in due course Portsdown 5. The PCB actually connects to the GPIO on the Raspberry Pi. It doesn't use USB, it just sits on top there. You can see the GPIO connectors there. And a new PCB is under development. This is a prototype. Uses the RP2040, the same microcontroller as is used on the Raspberry Pi Pico. And we hope to make it available as a kit next year with a target price of sub £100. So a cheaper option than using a Pluto or a Lime SDR to produce some very clean DVB S2. And thanks to Brian for all his work on that project. And you'll see more about that next year. So that's what's happening on the ATV front with Portsdown. Let's take a closer look at the test equipment, which has always been a bit of a sideline on it. But I think following the series of Radcom articles, there's been a bit more interest. These are the test equipment features that are there. You're probably familiar with Band Viewer. I'll go through the others as we talk about each of them and just familiarize you with what they can do. Band Viewer initially just used Lime SDR for a 20 megahertz sweep of spectrum. It now works with Pluto, which works with up to 50 megs. RSPDX gives you 10 megs, ASPI gives you 10 megs, and RTL SDR gives you 2. Various SDRs cover different frequencies, but the Pluto cover up to 30 gigs, and the RSPDX will cover down to 2 megs. Mainly intended as a PAN adapter, but very useful for checking transmitters. It won't give you absolute levels. You can't measure absolute levels like a spectrum analyzer, but it will give you accurate frequency. However, the dynamic range is limited by the SDR, and the RTL SDR is not good in that respect. Designed for weak signal work, this was out on a hilltop where I was looking for Rob M0 DTS 400 kilometers away. That's him on the left-hand side. I think that was Colin G4KLB with the 333 signal in the middle there, but I never did find out. That's how I use it portable, with the receiver on one side of my Portsdown double and the Band Viewer on the left-hand side, so you can see both at once. The other thing it does, which is useful if you're getting, if you're looking for other signals from your shack, it'll do peak hold. So you can sit it there, and if it sees a signal on certain frequency, the red trace there will show the history of that signal. And as I said, the Pluto will take it out to 50 megs. Recently, I've introduced a waterfall feature to that. You can either have a combined spectrum and waterfall, or just the waterfall. So that was how test equipment, probably the best feature of test equipment, I think. But it all started with the signal generator. Again, this started with the Lime SDR, but now I've interfaced it to multiple sources. And it gives you an approximate amplitude calibration. Some of the sources aren't so clean. Depending on the source, again, 1 hertz up to 30 gigs. Sources, the SDRs, the Pluto and the Lime SDR. ADF 4351 from the Portsdown 2020, and this feature is in Portsdown 2020. You can use the more expensive ADF 5355 to get up to 13 gigs. And also the ADE 9850, which is available from eBay, will take you down to 1 hertz. It'll also, as a specialist device, drive the LCOM, which is a microwave source, or the NOT SLO, another microwave source. And it gives you this really simple interface to control the frequency and some control of the amplitude if the SDR permits it, and an indication of the amplitude. Now, it says 1.5 dBm there. My sample gives 1.5 dBm. Yours, I would say a plus or minus 5 dBm tolerance on that, but you do know roughly how much signal you're putting out. This is my AD9850, which was cut out of an old printed circuit board and wired up like that. And it, I actually put it in a die-cast box, so it looks nice, but inside it still looks like that. You don't have to have things perfect. Right, once we've got band viewer working, for a long time I've measured noise figure using a Botanker noise figure meter. I have recently got rid of that and replaced it by using the Lime SDR, or in fact the Pluto now, to measure noise figure using the Portsdown. And this is done by switching a noise source on and off. I wrote this up in Radcom, sorry, in CQTV, and more recently in Radcom. So what do? You have your Raspberry Pi at the top there with your 7-inch screen. You need a switched power supply unit for your noise source and a decent noise source. You then connect that to your device under test and either your Lime SDR or your Lime Mini. Now the SDR has to be operating its linear region, so in the middle of its sort of level region. You don't want any other significant signals in the bandwidth. Things like mobile phones in the shack or other transmitters can cause problems there. And you need to think about what bandwidth you're measuring in. You know, if you've got a 144 megs preamp and it's only optimized from 144 to 144.5, you can reduce the bandwidth you measured down to 500 kilohertz to do that. Digital noise in the shack can also screw up the readings. Calibrated noise sources, difficult to get hold of, or certainly at a reasonable price. But RF Design still sell the BB Gen, and you can buy this through Kevin G3AAF, and that's probably the best approach if you need one. Mike MJW did a noise source switching power supply unit for us, and this will provide either 28 volts or 12 volts, a clean supply, and interface directly to the Portsdown. And that design appeared in CQTV. This is what the application looks like. You've got the spectrum there on the left, so you can see if there are any interfering signals. A meter showing the noise figure, and gain adjust controls to make sure your Lime SDR or Pluto is in its linear region. You can actually calibrate the system, and when you calibrate it, you take the device under test out of circuit and press calibrate, and it'll give you device and noise figure and gain 0. You then put the device under test back into circuit, and this is one of my 77 preamps, came out at 0.8 dBs and 23 dB of gain. This is my masthead preamp. So it'll do those functions, but it's not an exact science. You need to look out for this digital noise. You minimize that. And use some attenuators for error checking. So if you measure a noise figure of 0.8 of a dB, put a 6 dB attenuator in front of it, and it should measure 6.8. And then you know you've got a fairly good assurance that you've got the right reading. With very low noise preamps, you need to be aware that if the VSWR, or in fact the match of your noise source changes between noise on and off, it will change the reading. The other thing that's useful for aligning receivers is actual noise level. And this was intended to help aligning aerials for ISS HAMTV reception that Noel will talk about later, using sun noise. So this indicates average noise power. It can either be relative or absolute, but it can also indicate carrier level, again, relative or absolute, and using a Pluto or a Lime SDR. The display looks very similar to the noise figure display. This one capture here, I need to thank Gareth G4XAT for. He was using a Lime SDR there to look at sun noise on his HAMTV ISS setup. The spectrum there shows the noise spectrum. The peak in the middle gets ignored in the calculations. I null that out. And if you press the establish baseline button, you can set the 0. So you can do that on a bit of cold sky. And if you then sweep the dish across the sun, you'll get a plot and meter reading for sun noise. And you can see there, Gareth swept his dish across the sun twice. And you can see there are some side lobes there, but you can see the sun noise come up and go down, and then you get the side lobe. He did it twice in that plot. So that's for measuring sun noise. You can measure relative noise. So if you put a broadband DATV signal up in half the spectrum, you can measure how much higher it is than the quiet part of the spectrum there. And you can do the same with a carrier. And the green line on the spectrum there shows what the carrier it is measuring. And again, you've got the plot. That's for carrier to noise. And you can also measure absolute carrier. Now, both the noise figure test set and the noise test set, if you touch on the bottom left quadrant there, you can get big numbers up for the reading. So if you've got the display the other side of the shack and you've got your head in a piece of equipment and you're trying to look at what the reading is, you can get a larger number up just by tapping the bottom left quadrant. If you tap it again, the detailed figures will come back. Next thing I want to talk about is the power meter. Now this is uses an analog devices chip, or at least a Chinese clone of it, the AD8318, and a MCP 3002 analog to digital converter, which interfaces to the Portsdown. Nobody's asked for more sensors yet, so there aren't any more sensors yet. A very simple interface circuit. You can see the AD8318 module on the left there, fed by 5 volts. The MCP 3002 on the right, bottom right, with its own regulator, and that just interfaces to the Portsdown. Made a big meter face on the Portsdown screen for it, and there is some inertia and so on in there, and you can measure either dBm or milliwatts/microwatts on it. It uses a lookup table for linearity. You can either use your own lookup table or enter your own, or use the existing one if you think your sensor's pretty similar to mine. You can also enter a calibration factor for different bands. And if you put a 30 dB attenuator in or something, you can enter that and it'll do all the calculations for you. It's really intended as an alignment tool, not an absolute power measurement tool. It'll give you an indication of power measurement, but it's not as good as an HP432 for absolute power measurement, of course. Now, if you combine the signal generator with the power meter, you can make a sweeper by adding some automation, and that's what I've done. So this is how you would set it up. You have the Portsdown at the top there with a line. I hope to extend this capability to Pluto in due course. probably an attenuator before your filter or device under test, and then another attenuator before your power head to make sure you've got a good match. And then you set up the start and stop on the sweep and how many points you want. And you can do things like checking a filter. This is a filter I use in my HAMTV ISS receive setup, which is centered on about 790 megs. And you can see it's quite a reasonable response there to keep out all the Wi-Fi. This is on the IF of the system. So you can check filters with this, and you can tweak filters. If you use lots of samples, like you can set it for 500 samples and get a really good picture like the one I've just shown you, but it's quite slow. It's slow, it goes across the screen really slowly, which of course is no good for if you're trying to align it. If you want to align a filter, you can reduce the samples down to 10 or 50 and you get a faster sweep. It will respond to spuri from the source, so keep that in mind. And currently only the Lime SDR. Now, using the same plotting software, you could make an XY display for your old spectrum analyzer. I have an old HB141 spectrum analyzer, and of course the CRT is going a bit soft on it. So I wanted a decent display, or something that, and also something that I could do screen capture with. So I used a couple of an MCP3W2 in an interface, and you can just capture it from the X and Y outputs of the analyzer. I've also done a circuit for the HB85509, which is my current analyzer. Very simple interface, quite similar to the power meter interface, but there is an op amp in there to do some level shifting. Something a little bit different. I noticed on Twitter, I think it was, that the Parkside PDM 300 meter, you could modify it for an RS232 output. Now, this is a cheap meter. I won't make any claims for its accuracy, but you know, it's reasonable. And you can add an opto isolator on the serial output and interface it to your Portsdown. I use it for as a logger for rechargeable batteries. Or you can get a big display. Again, this is something you can see across the shack as opposed to the LCD display. It's only implemented for voltage at the moment. If I find a role for it, perhaps I can implement it for other ranges, but voltage is all it's implemented for. And I've automated a battery test on it. This was a lithium-ion battery that I had. It's a 3-cell lithium-ion battery. And I wanted to check its capacity. You can set up the current you draw, either constant current or resistive, and calculate the capacity. You can also set a cutout voltage, at which point the load gets disconnected. And you can see in this case it was 9 volts. And at 9 volts, that's 3 volts a cell, we got down to 2 ampere hours on this battery. So that's also available in the Portsdown test equipment suite. Now, to connect all these to your Portsdown, you know, clearly connecting to a GPIO is fraught with difficulty. It's very easy to short the pins and so on and blow up your Raspberry Pi 4 or interface. I use a 25-way D-type and bring out a number of the GPIO pins to this D-type. I define the interface in CQTV, and now most of my peripherals plug into this interface. Although, of course, the Pluto and the Lime plug into the USB interface. So in summary, all those peripherals can provide, with the Raspberry Pi can provide a really capable test setup for your test bench. We've tried to document all of them on the BATC wiki, and I encourage you to go and play with them and come back to me with any ideas for further test equipment features. Before I go into questions, I just wanted to mention one other project I'm working on. I recently got hold of an old spectrum analyzer, an HP spectrum analyzer, and I'm trying to replace the IF section of it with a SDR and a Portsdown 5 essentially. So that'll be a fixed frequency receiver on 300 megs, the IF of the Portsdown, that'll enable you to do spectrum plots using the sweeper in the spectrum analyzer. That's again a long-term project, and I don't think that'll be finished for a year or so. But that's the sort of thing I'm working on in addition to Portsdown. So that brings me to the end of what I wanted to talk about. But more than happy to take questions from the floor. Thank you very much, David.
Thank you, Dave. A good update on what is a very popular project, probably one of the most popular projects, I guess. Anyway, if you have any questions or comments now to make to Dave, this would be a great time to do it. We've got a couple of queries for you, but please do it now, either on BATC chat or on YouTube chat, and we'll be sure to read them to Dave. So the first one I think that came from Mike G0MJW and says, Dave, I was wondering if you could use the Pluto transmitter as a noise source via a suitable attenuator, or is the leakage too high? Maybe with 2 Plutos or Limes, for example.
I think, Mike, the leakage would be too high to use the same Pluto as you're doing the receive on. But it would be conceivable to do it to use a Lime or a Pluto as a noise source and a separate SDR as the receiver. That's one thing I haven't looked at, but probably quite easy to do. And I probably actually wouldn't use noise. I'd probably use a QPSK signal, which the detector would see as noise in the same way. And then I wouldn't have to write any new code. But that's a great idea. Thank you.
Okay, yeah, Dave, thanks. And Mike, thanks for your question. Do get those questions coming in now, because I've just got one more left at the moment. And this is from G8YTZ. The web control will be fantastic, he or she says. Love to have H.266 decoding as a future feature. Is this conceivable or on the roadmap?
No, Justin, H.266 is pretty unlikely. It would probably need a hardware decoder, although I must admit I haven't tried the Raspberry Pi 5 in software decoding of H.266. Certainly all the decoders we're currently using are software decoders on high-end graphic cards. The latest version of VLC, the development version of VLC, I believe, has H.266 decoding in it. But I have not yet succeeded in loading the development version of VLC onto the Portsdown. So it's certainly something to look at in the future, but we're not there yet.
Okay, Dave, thanks. I don't think I've got anything yet else come in. Just generally on the Portsdown, this has been a really popular project and seems to have a lot of longevity, doesn't it, for the club? Do you see it as someone that's going to continually evolve?
I do, but I feel we are reaching the limits of what it can do, what the platform can do. And I think the key to that is exploring the new features of the Raspberry Pi 5, what we can do with the increased processing power, and perhaps some of the AI features. The Raspberry Pi Foundation have released a hat, I think they call it a hat plus, because it does a bit more, that does a co-processor to do AI processing. And of course, they've just released a new camera that includes AI processing in the camera. Now, it needs people cleverer than I to make those do perhaps H.265 encoding, or perhaps in due course H.266 encoding. And that is where we can really get some traction. But I'm keen, of course, that the project continues to support those who've built Raspberry Pi 3 based Portsdown 2020s, and of course the Portsdown 4, and we don't leave those users behind, and it doesn't become a bit of useless shelfware. Even if it is to some extent shelfware for some people, it remains usable. And with continual software update, Portsdown 2020 is now 6 or 7 years old. And laptops of that sort of age, Windows laptops of that sort of age, are starting to be unsupportable. Well, Portsdown 2020 is still supported. Now, I'm wondering how long we can keep that up, but I'm determined to keep that up as long as possible.
Yeah, thank you, Dave. I mean, something you mentioned, it might be a good time to mention this with so many people watching this as well, that although you have been the kind of head of the project and bringing this all together, you said yourself there's something maybe you can't do, but there might be a club member watching this now who could help you with something like this. So don't be afraid to contact you if they think there's something they can help you with maybe particularly on the software firmware front for this AI.
Absolutely. The Muntjac SDR project that I mentioned is a case in point. Brian has developed his part of it, and I've given him some hints and help as how to best design it so that in future it will work with Portsdown. And we're now at the stage where I only need to change a couple of hundred lines of code, and I'll be able to incorporate that into Portsdown. And I'm more than happy to do that and incorporate other people's ideas and code into the Portsdown code.
Lovely, Dave. Yeah, so hopefully people will get in touch and help, and this becomes a collaborative project that evolves. So a couple of other questions for you. Steve M0MOI says, Dave, when using the Portsdown as a signal generator, it would be handy if a simple on-off modulation was an option.
Right. Excuse me. Yes. Now, if you use the BATC Express as a signal source, that feature is supported. It's a lot more difficult to do with a Lime SDR or a Pluto the way it's currently designed. I'll have a think about whether I can do that with a Lime SDR or a Pluto. But yeah, it's a very useful feature because it is already there with the BATC Express. And I'll add that to the can I do this ? List.
I guess there's a lot of those. Dave, thanks. Mike G0LJF says, I have a Jetson Nano box. Does P4 or P5 still support my boxed up Jetson?
P4 does. P5, I haven't looked at that aspect yet, but Portsdown 4 certainly does.
Great, lovely, thank you. Radio Gareth, sorry I don't have your call sign, Gareth. Could the PD4 volume up and down mute button areas be made 1/3 each?
Yes, simple answer to that. I hadn't thought about it. That is probably quite a simple change. Actually, the more difficult bit, I can change the touch overlay, the actual touch response very easily, but it means I need to make up a new graphic, like the graphic I showed. But I will add that to the to-do list, Gareth.
All right, thank you. Finally, our friend Noel GTZ says, how many SD cards have we shipped? And in case this is related, and I think it might be, underneath that, Radio Gareth has put that 138 rides have been sent since December 2020. So I guess that may be the answer.
No.
Okay, they're unrelated.
Right. They are related in a way. In the BATC shop, we sell SD cards for the Portsdown 2020, the Portsdown 4, the RIDE receiver, which is what Gareth is referring to, and the video source. Now, Gareth has shipped 138 RIDE receiver SD cards, and before he started shipping them, I certainly shipped a good few. So there's over 150 RIDE receivers gone out there. Portsdown has been a real success story. We're approaching 1,000 SD cards shipped from the BATC shop now. Which is quite incredible. And the other thing I keep track of is how many unique users of Portsdown we have. Now, this includes those who've bought all the add-on boards and so on, but we're up around the 600 unique users of Portsdown. So I'm really heartened by how much interest the project has generated.
Absolutely, Dave. Well, that's a good point to probably end now. And just to say on behalf of all those people who've benefited from the projects and particularly Portsdown and all of your work, thank you very much for that, what you do for that, and also, of course, what you do for generally for the club as treasurer as well. So thank you very much to Dave, GHGKQ. Thank you.
Thanks, David.
Now, coming up shortly, we've got Michael, EA7 KIR, coming from a warmer place than this, I think, talking satellite by touch. We'll see you soon. and welcome back. Michael EA7KIR was first licensed as G8WAA after working in UK commercial TV production for many years. Now he's living in the Costa del Sol, lucky him, and enjoys building and experimenting with circuits and systems to use with the QO100. And today he's going to give us a presentation called Satellite by Touch. As before, please feel free to ask questions or make comments on BATC messaging or YouTube chat at any time. And please include your name and your call sign in each message. Anyway, back to CAT24 and welcome Michael. Hello, Michael.
Well, yeah, good morning, David. Unfortunately, I couldn't hear a word you said then for some reason. I've no idea why.
Okay, well, we can hear you fine.
I don't seem to be getting the audio coming back on Zoom, so if you get that working by the time we get to questions, that'll be helpful.
Okay.
Very strange.
Right. Okay.
Okay. Yes, I don't know what you said. If you did mention the title, Satellite by Touch, I just wanted to mention that why I came up with that. I think my mind works different to everybody else, but in the back of my mind was that song, Catch a Falling Star, put it in your pocket and save it for a rainy day. I don't know. Anyhow, where are we? Okay, I'm going to talk about what's going on now. This. No, not that. Here we go. It's messed it up already. Okay, I'm going to talk about my QO100 receiver and transmitter and the PA side of things. And I'll show you the shack as well in a moment, which includes an HDMI switcher, a camera obviously, a microphone, phantom power preamp, a pair of small JBL powered speakers, two 12-inch monitors, and audio and monitoring on loudness meters. And this is basically what it looks like in the shack. Okay, I've had to throw out all the HF and VHF radio stuff for two reasons. One, I virtually stopped using it altogether, and second, I just don't have space on the desk for it, so it's in the storeroom at the moment. The antennas are still on the roof, of course, and I'll show you those later. So I can't go into too much detail on all this because it would take far too long, and I've put far too much on the running order. But from the left, you can see I've got the switchers, the HMI switcher. It's made by AV Matrix. It's got a preview screen. Below that is the LU meter, and above is the receive monitor. In the center, I've got the PC. It's actually a Macintosh iMac. You can see the camera next to it and the microphone. And on the right, I just use the Mac for the chat, actually, just for the chat. That's the only thing. So everything's external. And so it's all in two boxes on the right-hand side. And there's a closer look at them, the two boxes. On the top is the transmitter, and on the bottom is the receiver. Now, these are the third generation of things that I've built. The first generation was working on a Mac. I built the interface on a Mac, and for that I wrote it in Swift with all the external hardware on the roof, including the Pluto and everything. Everything was up there, and that worked. But there were problems. So I built a second generation, and that was all written in Python, and that's introduced the two boxes, okay. But that had limitations as well. It wasn't fast enough to cope with the number of buttons that I've got. As you can see, there's quite a few buttons. If I just go, I just skip ahead there. So we're now on using a language called Go. Next slide, whatever that is. Oh, there's a better look of the transmit side of things. Okay, and you can see the LU meters below, which I'll show. Just a minute, I'm just looking at, I think you turned down, no, I didn't turn my volume down. It's up, it's even up right now actually, but for some reason I can't hear you. I can't hear myself coming back on the...
Can you hear me now, Michael?
On the Zoom either.
Well, we'll work this out later.
If you turn it up, yeah, it is turned up.
Can you hear me, Michael?
It's definitely turned up.
Okay.
Absolutely. Okay. So that's basically all of that side of it. And where are we now? I'm losing my place now. Okay, so here's a closer look of the transmitter. You can see it's a touch screen, hence the title of this thing. It's got buttons across the middle row, one for the band, one for the FEC, and one for the frequency, with a decrement and an increment button to either side of the labels, which are labeled beacon and so on. The rest of it, this is the receiver, I'm sorry, this is the receiver, of course. Then at the bottom, you've got your usual sort of data coming in from the Longmind software, but it's decoded in Go. So I'd like to have a few more things on there, but it's kind of running out of space, really. And what you do is you pre-select your parameters, in other words, what band you're going to work in. The bands are beacon, which is just one frequency available, okay? And then you've got wide, narrow, and very narrow. And that limits intentionally the number of frequencies you can select and the FECs. So it keeps you following the rules, if you like. And then you press the tune button, and that programs the Longmind software onto the frequency you actually want. So, nothing else on the front panel, just an on-off switch and a meter. So behind, we've got a very simple interface now for this self-contained box. We've got power in on the left, obviously, an F connector for the LMB, HDMI input from the switcher, and a local area network connector. Looking inside, that's it, the whole thing. Okay. So we've got a couple of power supplies. There's a 12-volt switch mode power supply on the right, and then a 5-volt buck converter down to 5 volts. So the 12-volt feeds the BATC mini tuner receiver, and the 5-volt feeds the Pi. But it also feeds the two fans on either side of the chassis, which you probably noticed, but you'll see them later in the transmitter if you missed it. And here is the Pi mounted on the back of the LCD. I've put two aluminium brackets which press it against the front panel, and you can just see little foam pads which press it up nice and firmly, so that works quite well. And here's the BATC receiver, which everybody uses, of course. It's a very short lead into the Pi. Okay. So that's the receiver. It's really bog simple. It's just that I've put it all in one box. But the difference between this and the Portsdown is it's very limited, very limited on facilities. It's just a receiver, that's it, you know. It's nowhere near as advanced as the one that David has just described, which is absolutely quite incredible. So I'm not recommending anybody to copy this design. I'm just showing you what I do. So moving on to the transmitter, which is a little bit more interesting. Again, a very simple front panel. Same idea for selecting. You select what band you want, you know, wide, narrow or very narrow, and then the other parameters, which include the codec, video, audio bit rate, mode, FEC, frame size, 1080p or 720p, and how much power you want to send up to the PA. It's identical to the receiver, but instead of data, we have DX parameters. The parameters are sent to the Pluto when you press the tune button again. So there's a tune button. It's exactly the same principle, and that programs the Pluto, and it also programs a hardware encoder, which is in the box. And then at the bottom right-hand button is the press to talk, which turns red when you press it. So on the back, it's very similar layout, very simple. Power in on the left, an N connector going up to the roof, HDMI in, an Ethernet connector. There's a little round thing, the round connector, which is a 3.5mm stereo jack plug, and that carries press to talk from a GPIO via a little bit of a little sub-circuit, which I'll talk about in a minute, to the LU meters, because the metering device is my monitoring device for audio. So it provides a mute facility. So when you press to talk, it auto mutes the receiver. So you don't have to do it yourself. It makes life a lot easier. And of course, an Ethernet connector on the extreme right. Looking inside, we've got the encoder down on the left-hand side. You can see the two fans now. There's one either side of the cabinet. They suck air out, so they're extract fans, and the intakes are slots in the bottom of the chassis and the top. The chassis, by the way, is made by a company called Retex, which is actually manufactured in Spain, and they're a very reasonable price actually. So they do the job just fine. If you look in the top left-hand corner of the picture, you can just see a little bit of green. Well, that's the sub PCB for the press-to-talk interface. And what that does, it protects the GPIO outputs so that if you shorted them, because even when you stick the socket in, you could actually short the thing out. So that prevents that. And it also converts it into a kind of pseudo-balanced output, which is a trick you can use for audio, really. Basically, you just put a resistor in two legs of a twisted pair. So that's your current. You've got two current limiter resistors, and it's a quasi-balanced thing. So and you use a screen to chassis, but only earthed at one end. So you get galvanic isolation and protection all at the same time. And then, of course, you've got the Pluto in there and so on. Power supply is exactly the same again. 12 volt and 5 volt. 12 volt obviously feeds the fans, and the 5 volt feeds the Pi, the LCD screen, and the Pluto, and that works quite fine actually. I don't seem to have any problems with that. Looking closer at the Raspberry Pi on the front panel, you can see the GPIOs I'm using. The two on the right are feeding the sub-PC for the press-to-talk, and the ones on the left, the yellow one and the bunch with the yellow cable, that goes to an RF switch. Okay. There's a close-up here of the encoder. Now, this is I started with a different encoder, and it wasn't very good at all. And then I got this one, which is a bit better, but it's still producing soft pictures because I'm just not getting the quality that other people are getting. But I do have plans to replace that, and I might try putting a Pi 5 in there with FFmpeg and see if that is any better. That should improve things, hopefully. Okay, the Adam Pluto. It's a version CD. I've added a few heat sinks to this, and it's not in a case. I know some people put divider panels, all over the place, for RF shielding. But I'm not having any problems, so it works for me. The firmware is it's the original, well, not exactly the original one. It's firmware 2201RC. It's not the latest, as I said, but it does most of what I need. Because the latest softwares have just added extras like band viewer and auto tune and all that kind of stuff, and I don't need that in this instance. I toy with it, updating it, but I get distracted with other projects. Okay, so the two extra things that are in here. The top one is, the 20 dB amplifier, the Adam CN0417 RF amplifier, preamplifier. But I think a lot of people use that or something very similar. But the one at the bottom is an RF switch, and this just show it on the. This means that I can send. They are mounted on a case here, vertically to assist cooling actually. So on the right, it's going straight into this RF switch on the right hand side from the Pluto into the switch, and I put a 50 ohm dummy load on the second output termination, and then into the preamp going up to the roof. I've got a long cable going up to the roof, and it's absolutely necessary. Now the thing about putting the term on that is that if you're not transmitting, you finish up with a situation where the Pluto is terminated with 50 ohms. There's more to it than that, though. There are other advantages, and you can see it more clearly on the diagram for the RF switch. You can see that there's actually two built-in 50 ohm resistors in the switch itself. So by terminating one of the outputs with the 50, you finish up where, if you're not transmitting, as I said, the Pluto is terminated, but also the line going up to the roof is also terminated. So you're not hanging an unterminated feed. I don't know whether this makes any difference. It just seems like a good idea to me, because with the Pluto, for example, if you unterminate the Pluto and then suddenly terminate it, maybe it causes some kind of a disruption. I don't really know. I just did it because it seemed like a good idea. So nothing's left floating, in other words. The complicated part of this setup, some might say overcomplicated, and I would tend to agree, but it does have advantages. The Raspberry Pi is on the right. Now the Raspberry Pi only has one Ethernet input, one RJ45, but it does have 4 USB things. So we've got the LAN, local area network, coming in on the usual one whatever address, and the Pi is, the local address is 38. You can see that. I use dynamic DNS for this. I don't use static IDRIs. I like dealing with names, and it works for me. So I rely on my external router provided by Telecoms. So the Pluto, I've left bog standard, and normally it's like 2.1. I don't like tampering with the Pluto too much, so I just leave it like that. So I've arranged the USB, one of the USB connectors, to be Ethernet 1, and program that to be 2.10, okay, internally. So I've done the same with the encoder. I've copied the same kind of thing, but I've made it 3.1. So the switcher goes into the encoder, then it goes through an Ethernet to USB adapter. In this case, I'm using, what is it? I can't remember now. I think it's on another slide somewhere. And I've programmed the other Ethernet connector to be 3.10. Now this requires a lot of IP table rules, but there are benefits. I think it's less traffic on the LAN because the routing is internal, In other words, the encoder isn't sending its output onto the LAN and then getting it back again. It keeps it internal. But there are other advantages as well with the Pluto. And I can list the advantages here in this diagram. From my desktop PC, which is an iMac, I can also access these things. Like I can look at the documentation of the Pluto, not that you need to, but I can also look at the controller and the analysis page, and also the setup page for the HDMI encoder as well. And I can use, their names, the names of these devices. The Pi is called, the transmitter is called TX Touch. The receiver I've called RX Touch. It's original, isn't it? But by going on a different port, 8082, I can access these things. Now, these are very useful, certainly when I was writing the software for debugging purposes, because I could see that I was actually programming the Pluto as intended, and the same with the encoder. But it's also useful if I'm playing around with the video bitrate and I want to look at the analysis page on the Pluto to see, if it's bottoming out, buffer overruns and things like that. Although it's terribly confusing. So that's basically it for the transmitter. Very simple setup altogether, actually. I must have gone through that a little bit too quick, actually, because I think I'm going to underrun rather than overrun. I'll have to slow down a bit, or maybe we can have more questions. Anyhow, this thing works for me. As I say, I've gone through 3 iterations on this. I envy the people that can make use of the Portsdown, because it's got all those test facilities, and you can go out on the road with it and transmit and receive on point-to-point contests and all that. But there's nothing like that down here. I'm the only one. Okay, my only option is the satellite. That's it. So that's why I went this route. I would love to get other people involved down here, and I've got a plan for that. So that's something for the future. That's what I'm aiming for. Anyhow, up to the roof. As you can see, I've still got the HF antennas. The one right up at the top on the pole is a multi-band thing. It does 20, 17, 15, 12 and 10 meters. It's made by Big Signal, and the model is called a Skyline. So it's a Big Signal Skyline. It's a full wave wire antenna. Now I chose it. It is omnidirectional. It's omni, which but I did this because it's the easiest thing to do, and I don't want to get into 1 kilowatt power amplifiers or anything like that. So yeah, it's pretty useless actually. But they're supposed to be very low noise, and it is actually. It's pretty good. It's pretty good. But it's also very low wind resistance as well. So that's quite useful. And then on the right, just above the dish, at the bottom, there's a 6 meter antenna. It's made by Diamond Antenna. It's an A502 HB. Just above that is a 2 meter centimeter 2-band signal receive transmit antenna, also made by Big Signal, and that's full wave as well. Again, a wire thing. And then right on the top, we've got an antenna amplifiers antenna. That's a bit of a mouthful, isn't it? And that's a PA 1296, and that does 23 centimeters, and I get absolutely nothing. Nothing at all. I've never heard anybody on that, and I've tried. I've put out CQs and all the rest of it. But that might come in useful if anybody ever starts doing point-to-point TV down here. The dish is a Gibbertine OP125. That's a 1.25 meter parabolic dish, and I extended the arm a little bit, and it's got a Pluto on the a potty on the end of it, of course. And below that is the enclosure, which there's a closer look. It's again, this has seen the 3 iterations of its internal gubbins, and you can see I put an intake fan on the bottom left, and there's an extract fan in the top right, which of course you can't see, and you can see also that I've put the cables in trunking as much as possible. A little bit closer view of the box. From top to bottom, we've got the PA on the top shelf, then electronics on the second shelf going down, and then power supplies and mains distribution at the bottom. Attention to safety, yes, I'm into that. Okay, slightly closer view. Notice the green and yellow grounding blocks in the bottom left. Yes, I'm really into earthing things. It's about the only thing I understand, actually. The space around the shelves, though, each shelf there's space in front of it when the door's closed, there's space behind it when the door's closed, and there's also space to the left and right. And this is for air circulation. So it gets sucked in. The 7-inch fans, and they're pretty powerful. So, you know, there's a lot of turbulence in there, which helps keep things down. Even some of the cables are labelled, you might notice, which is unusual for amateurs, isn't it? Well, it's unusual for me. But you know, if I need to disconnect a few to take something out, you know, it helps put it back together, doesn't it? Okay. The mains distribution. This started in iteration number 1, when I was just beginning all this stuff, and I went really overboard, as you can see, but they're still here, so I still use them. So we got going right to left, we've got the main breaker, which is you know, an earth leakage protector thing, and then there's double pole breakers for the 5-volt power supply, 12-volt power supply, and a 28-volt power supply. To the left of the breakers is a 24-volt AC transformer, and that's to power the 2 contactors to the left of that. One is for switching 230 volts to the 12-volt power supply, and the other is for switching 230 volts to the 28-volt power supply. Each contactor is driven by smaller relays, which are mounted on the back of the Raspberry Pi. I'll show you those in a bit. So the power supplies themselves, that's the 28-volt thing. I really can't remember how much power it puts out, but when I'm transmitting, I'm pushing out about 7.5 amps. So it's at least 10 amps is this power supply. So that's 280 watts, isn't it? So it's probably a 300-watt power supply. I can't remember. And they're all made by the same company, I think. 12-volt power supply there, and the 5-volt power supply there. Okay, that's really interesting, isn't it? Yeah, okay. Right, so the Raspberry Pi itself is kind of hidden under this wave-share relay hat. It's 3 relays. Okay, and as I said, one supplies the 12-volt contactor for the 12-volt power supply. Another one supplies the switches on and off the contactor for the 28-volt power supply, and the third relay supplies 5 volts to another RF preamplifier, which I've got up there, because they tend to get a little bit hot, these preamps. I've put heat sinks on this thing, as I did on the transmitter. There was heat sinks on that, and I've glued them on the front and on the back. But on this one, I've also added a temperature sensor, which is glued on as well. And it's mounted vertically, as I did in the transmitter, to assist in convection cooling. But It works, but they do get very hot, these things. In fact, there's actually a label on these preamps that say, do not touch, very hot. No problem so far, and it does get very hot here in Spain, you know, anything up to 35 degrees in summer. So the preamp enters on the left of a Burt Modem 100 watt power amplifier, which is absolutely superb, before passing on to the potty upstairs. There's 2 fans on the heatsink. It's through air. It's like a tunnel. One is an intake on the left and an extract on the right, which is right next to the extract fan on the enclosure itself. So that seems to work very well indeed. And of course, that only comes on when the 28 volt is applied. Closer look of the transmitter itself. Now the power amplifier, it's divided into 3 compartments. On the left, you've got the input on the left, and that houses the driver and also the bias input. Now, I don't switch the bias. As I say, I use an RF switch downstairs. So the bias is permanently connected. You can see the red wire going across, and that's permanently connected to the main 28 volts going into the final, which is the center compartment of this box. And then the right-hand compartment of the box houses a circulator. And I put a circulator in because I thought that was a good idea. I mean, for example, if the potty fell off, you know, it saves the PA, doesn't it? Seems like a good idea to me. But notice the thick copper plate that Bert's built into the PA. I got him to drill an extra hole in the copper, and I've stuck a temperature sensor in that as well. So that seems to work as well. And yeah, that's pretty good. And then it obviously goes out and up to the dish on the other side. Yeah, okay. So that kind of just get myself sorted. That kind of it works, you know. I really don't know too much about the RF side of it, mainly because I don't have the opportunity to do things that other people do. So I tend to concentrate on software and things. And I mean, I'm not an engineer in any sense, neither in electronics or in software. I just dabble. I'm an amateur, but I use the internet a lot, you know, and find out what I need. But the thing about building things myself is that I like the learning process, you know, rather than, you know, I mean, you can go out and buy an ICOM 7300, for example, and never know anything about the technicalities, because it's a beautiful, but I've got one. And I just wanted to design it myself, you know. I'm not trying to say this is better than the Portsdown. It is not, but it works for me, and that's the thing. So the other thing I can talk about, because I think we've got time, yes we have, is the audio side of thing. Because basically I worked in broadcast TV all my life, really. I joined ABC Television, ABC Weekend Television, which most people won't have even heard of unless you're my age and you lived in the north of England. But they were the weekend contract for ITV. Granada did the weekdays, and the studios were known as Didsbury. They had studios in London called Teddington, but they didn't transmit from there. They just did 1 or 2 shows, and we did all the other stuff. And I joined in 1962 as a trainee, and after that they lost their franchise in around 1969 or 1970, I think it was, and I moved over to Yorkshire Television, and went into the film department to start with, and then I moved into the studios, and eventually became a sound supervisor. I stayed with them 20 years. The great thing about joining ABC, though, at such a young age, and I was only 16, was that I joined as a trainee, and the first 3 years I worked in a supernumerary capacity in every technical department, including sound, racks, which is where they tweak the little knobs to adjust the black level and the, I can't remember what it's called now, but there was a knob that did this to the waveform. Some people know Noel, and other things, exposure and all the rest of it. I worked in there for a bit in a supernumerary capacity, but when I say supernumerary, they used to let me have a go, you know. I even mixed wrestling. You remember when ITV did wrestling? I did a bit of that as well, the sound. And you learn a lot, because in those days there were no limiters or anything. I'm coming on to that in a minute. There were no limiters. You had to actually use your fingers and control the faders. And believe me, things like football matches and wrestling, in fact, any live sports event, the dynamic range is horrendous. You know, it goes from very quiet. Take tennis, for example. We never did tennis. But that's extremely quiet, and then suddenly, wow, you know. You've got to control that by hand. Okay, so metering was very important. After Yorkshire TV, I was with them 20 years, and then I took voluntary redundancy and set up my own company called Sync Facilities, and I built an audio dubbing suite with what was absolutely high tech at that time, an AMS audio file. And after a few years with that, I changed premises and added the first all digital edit suite for video edit suite, based on digital beta cam. Everything was digital. The vision mixer was in the edit suite. Everything was digital. Even the sound mixer was a Graham pattern digital sound mixer, which connected to the editor controller software. I had a graphics department with employing a graphics person to do that, and I employed another guy to do the sound and an editor, and you know, I dealt with the customers at that point, and it was great fun. It was great fun until I retired and came to Spain. So just going back to the sound then. Okay, let's get on with the show. We will in a minute when I get this slide right. Okay. During my time at Yorkshire TV, I was building audio mixers, and I started building audio mixers even before I left school, actually. But on one of the audio mixers I built during that time, I wanted I'd been using VU meters because PPMs were far too expensive. PPMs, by the way, peak program meter. Okay. They were introduced by the BBC originally, and then adopted throughout Europe, certainly throughout ITV and BBC and South Africa and everywhere. They were all over the place. But they were quite expensive, the movements themselves. So I devised a little circuit that could turn a VU meter into something that began to look a little bit like a PPM. In other words, it had a faster response time, but a slow decay time. Okay, and I wrote a little article about it and sent it to Studio Sound and got it published. And that was in 1971. Okay, they called it a POVM. I didn't invent that name. POVM, peak orientated VU meter. Aren't journalists clever? Okay. More recently, I wrote software for this. This is a PPM, and it runs on a Lilico T-display, and it's written in C. I use VS Code with the platform IO extension, and this is works to full BBC peak program meter specification, which, as I said, is used in the UK, or was used in the UK, Europe, and South Africa. It's the T-display itself is an ESP32, So this is a stereo meter. So it's got two needles, a red one and a green one for left and right. And it uses a TFT SPI graphics library for the actual picture. But this is old hat now. The world has moved on following the war, the loudness war, which was brought about by TV commercials being far too loud. So the EBU, after years of research, and the BBC and so on, they did lots of experiments, objective, subjective, you name it, with work groups and everything else. They eventually came up with a specification for loudness units. Okay, and that is the modern way of doing it now. But at the time, you know, if you wanted to buy one of these things, are very, very expensive. And now you can, it's all done in digital, and the whole algorithm was designed for digital. But, you know, as I say, I'm not an engineer. I don't understand digital. You know, I'd need to design a PCB with a digital converter in my instance, because I want analog in. So I thought, well, I'll build one. I'll build one myself, and I'll build it all in analog, or at least most of it, because there is an Arduino in there, and that's a digital, isn't it? But all the rest is analog. So I've got 2 meters. Okay, this is the operational side of it. I built this for operational reasons. Okay, mainly because I wanted a mute control. So on the left, I can monitor my outgoing audio level, and the idea is you keep the audio level in the green part as close to 0 as possible. And if you do that, you're putting out the EBU recommended volume level. And on the right, you can measure the incoming, your receive audio. So you know, when you go on air yourself, you can see yourself coming back. Obviously, there's a delay. But if they're both waggling about in the same region, you're pretty assured that you are actually getting out there. So there's no need to, have I got audio? 1, 2, 3. You know, you don't need to do that. You can actually see it's working, which I find quite useful. But the most useful part of all is the auto mute thing. And so the buttons on the right, the top one. First of all, the top one, you can select between your speakers, your monitoring speakers, listening to your receiver, which is the green, when it's lit up green. And if it's lit up red, you can actually listen to yourself, because you'll get a howl round if you've got your mic attached. But it's useful if you just want to listen, to check your microphone is working, but also if you wanted to check the level of some background music or video music or if you're showing a video and you want to talk over it, you can just listen to it and think, oh yeah, that'll be about loud enough, so that it's useful for that. But I leave it in the receive position, obviously, and then the center button selects whether you want auto mute or not. If it's on green, which is the default, then it's on auto mute. So the bottom button is actually a mute button, which you can use for manual if you're not in auto. But if you are in auto, when I press the talk on the transmitter, the red button on the LCD screen, this little button lights up red and mutes your speakers. Very useful. On the back panel, very simple. So we've got 3 stereo jack connectors. One goes, the one labeled monitor goes to the speakers, and then the next 2, one comes from the receiver, and the other one comes from my transmission output. Now, where do these analog inputs come from? Well, in my case, I've got two monitors, 2 12-inch monitors, and they have a headphone output, so I just use those. So it's the headphone output from the TV monitors straight into there. And there's a preset control next to each one, so you can calibrate the whole thing. And how do you calibrate it? Well, the easiest way is to generate a tone in Audacity or something like that, and set it to the correct level, which is -18, is it, or 23? I can't remember now. I did document this somewhere. And then, fiddle with the preset until it reads right on the meter, and do the same with the receive. So you put your transmitter and to transmit up to the satellite and look at the level coming back, and then twiddle that one. So that moving along, that's the pressure torque input, which is from the GPIO, originating from the GPIO on the transmission, and power input. Very simple. So inside, I opted for ribbon cables to connect 3 circuit boards together. Originally, when in the original design, it was working out to be about 6 or 7 ribbon cables, but I managed to get it down to 3. So in the top left, there's a sub PCB, and that mounts the tactile buttons and the volume control. And then the meter, that's a sub PC as well. That carries obviously the pulse width modulation from the Arduino, and also to each meter. And above that, there's 2 little LEDs, red ones, and those are peak indicators. I don't know if you noticed them on the previous picture, but the thing about measuring, I'm running out of time, aren't I? Just let me speed up a bit. Forget that, okay. Let's just move it on a bit quicker. So we'll skip that one because I was already talking about that. Okay, so the main circuit board itself, as you can see, it's kind of divided into sections. There's a lot of duplication going on here. So I've put a red circle around one part of it, and that part houses what's called a K filter, which is an audio filter which has a particular response dictated by the EBU specification, followed by a precision rectifier, and then a low-pass filter before finding its way into the sorry, it's not an Arduino, it's a Arduino Nano, Pluto Nano. I can't remember. Perhaps a diagram will explain better what's going on here. Anyhow, mains on the path on the PCB. You notice mains. Oh yes, very dangerous. Okay, so how does it work? Well, in the top right, if I just take my picture off there, okay, there's input gains and trims for the receiver and the transmitters. Okay, those split off to an analog switch IC, which also does the mute function, and then onto the volume control and out. So the top block is identical again to the bottom block. So there's a lot of duplication, as I say. And the top block is, each left and right goes through its own K filter, precision rectifier, and low pass filter, and then eventually into the Arduino Nano. It's an Arduino Nano Every. Okay, it's faster than the normal one, and cheaper actually, and more memory. And not many people know that. And then on the right hand side of the Nano, we've got pulse width modulation to each analog meter, status LEDs from the buttons and everything, and on the GPIO inputs for the remote input and the tactile switches themselves. Okay, so all that kind of works. Okay, I think how are we doing for time now? I'm slightly over, aren't I? No, I'm 2 minutes under. We're all right, so I can just wrap up nicely now. There's too much in there, wasn't there? Too much. Anyway, I hope that was interesting. I certainly wouldn't recommend anybody building any of this stuff, but I enjoy doing it, and I'm sure there'll be a 4th iteration. I have ideas for that as well, actually. What I really fancy, there's two ways I could build a 4th generation one. One is to, first of all, use 19-inch rack stuff, but have no buttons, switches or touchscreens at all, and control it all over software, which is going back really to iteration number 1, but instead of it all being on the roof, it would be down here. The other way, which is quite attractive to me, is to, again, do away with the touchscreen and actually put real buttons and switches and knobs, and a physical interface, none of this new stuff. Touch screens are great, but I don't know, sometimes they work and sometimes they don't. You know, it depends how greasy your fingers are and, you know, how big the buttons are. And if they're not big buttons, you can't hit the right button. I struggle. I find it extremely difficult to send text messages on a phone, for example. So that's it, I think. I think we've done it. I think I've stumbled. I hope I've got the audio back. Otherwise, I won't be able to hear the questions, will I? So I'm going to hand over to you, David, and hope.
Well, can you hear me, Michael? Can you hear me?
No, I can't hear you.
Okay. I'm going to do something I haven't done before. I hope you can read that. But I'll keep talking, as they say.
Where's the volume control? I can't see a volume control on
I wish I could help you.
Zoom.
I must explain to everybody at home that the last thing Michael said, we talked to him just in the break before his talk, and he just said, right, I'll now need to turn you down.
Just
I think
below.
he was thinking there was going to be feedback. And of course we said, no, but it was too late. And he did. So being a sound engineer, he'll know that normally you get feedback problems. But of course Zoom cancels that out.
It is turned up.
So I hope, whatever you did, Michael, before the break, I don't know what else I can do.
It is turned up. But I'm using the volume control on the Mac.
Yeah, I wish I could help.
So the Mac is
But we are
turned
live,
up.
as they say. First time I've ever shown my handwriting, I think, on screen as a message.
Okay, I'll watch it on YouTube then.
The trouble, well, I can't obviously talk, he can't hear what I'm saying. The problem on YouTube and BATC, as many of you will know, fortunately, because you're interested in this technology, is that there's going to be quite a lot of latency with those. I have got some questions, of course, that some of you have sent. I think we can try and send you some messages, but we're coming up, obviously we want to try and keep to time for 12 o'clock for our guest speaker then as well. So I'm hoping that Michael, if I keep talking, will find the volume control that he said to us just before his talk. Right, I'll turn you down now. And if he could turn that up again, that would be brilliant. We can't do anything from here.
Oh, no.
Can you hear me?
You can still hear me, David?
Can you hear me?
I've got the sound now on YouTube.
Right, okay.
No, that's gone again.
Yeah, the problem...
I think it's Zoom that's screwing up my computer.
Okay. Well...
I'm convinced.
Okay, there's not much I can say, Michael.
Oh, no, I've got it now. I've got your sound on.
Can you hear me?
Still hear me, David?
Can you hear me?
Yeah.
I think you might be hearing me in quite a delay.
Yeah.
But...
I'll put Michael's volume down.
Right, now we've turned your volume down, however, live, Michael, to not confuse everybody at home. We haven't got too much time anyway. I'm hoping that you can hear this, albeit a delay. So I'm going to read to you a question, and then hopefully you may be able to answer this. So we'll just see if it works. All right, can you hear me live now, Michael? Right, now we've turned your volume down. No, I think Michael can hear us by delay, but we'll still try it. We'll keep talking, as they say. So GB3MBA says, what software development environment does Michael use for Go? I'll give him a chance to answer this. So we'll just see if it works. All right. Can you hear me live now, Michael?
Yes, I can.
I don't think that's live, unfortunately, but Michael can hear us by delay, but we'll still try it. We'll keep talking, as they say. So GB3MBA says, what software development environment does Michael use for Go?
Okay. What software development do I use for Go? I use VS Code. It works for me.
I don't think that's live, unfortunately, but Michael can hear us by delay. But we'll still It's okay, Michael. Keep talking. Keep answering the question on Go, please. So GB3MBA says, what software development environment does Michael use for Go?
Okay. What software development do I use for Go? I use VS Code. It works for me.
I think we are going to have to leave it there. I think I'm not sure with its technical problems or maybe just an issue with Zoom, but sadly, Michael, I think we're going to have to leave the questions. We'll try and forward them to you. I could have done all sorts of things then to try and see if you can hear us live. Yeah, my Tammy M0TC is just off screen here, is just saying about comments and things on this. So,
Michael could comment maybe.
okay, yeah, I mean, Michael maybe could comment on some of the things, Michael, if you have a look on BATC or on YouTube. But I do fear that we're running quite short of time now to be able to do that. So I'm really sorry. It's a problem with Zoom, I think, in terms of the delay, etc. that we use. We use Zoom, by the way, to make contact with all of our guest speakers on this. But Michael, thank you very much for the talk. I know we've all enjoyed it. I particularly like to hear the word PPM meter come up because it reminds me of my days back in the Viva about 20 odd years ago, which they just don't talk to now. I work with a community radio station now, and they have meters, but they don't teach levels like they used to. And your project with the PPM meters and the LU meters is fascinating. I'm sure I speak for everybody in that, and to thank you for sharing that, the wonderful projects and engineering that you've done. We're going to wait. Oh, can you hear me, Michael?
Just wave bye.
I'm going to say wave goodbye. All right, but thank you very much, Michael. And we'll call it a wrap there. And I'm sorry for those of you who asked questions that we couldn't get to Michael in time, but I'll try and get them to him via email and get him to answer some of them. Coming up shortly, we're going to take a look at Allstar for Talkback. Just have a short break now. welcome back. As you may have noticed, the original programme for today has changed because unfortunately at the last moment Tom ZR6TG was unable to join us for his planned presentation on OpenTuner. However, at extremely short notice, last night, Martin GHKOE agreed to give us an informal talk on something he's very passionate about, using Allstar for Talkback. As before, please feel free to ask questions and make comments using BATC messaging or YouTube chat at any time, and I'll relay them to Martin as we go. So Martin, firstly, many thanks for doing this with just literally a few hours notice last night, and welcome to CAT24.
Right, thank you very much. For those who don't know me, I'm obviously GHKOE, King of England, and I was going to do a quick rundown of how I started, really, in ATV. I got out of school as soon as I could, went to work at a small store, which actually Woolworths, which a lot of people won't know, but others may. And my job was emptying all the stock coming in, etc., and sorting things out. I soon got out of there. And went to work in the TV trade, which about 3 to 4 different companies I worked for in the TV trade. And then a thing called harmonisation happened, which meant that things were closed down. Someone's trying to key up on Allstar, but we'll turn that off. Then joined a company doing sound and lighting in Brighton. That was looking after nightclubs, servicing the equipment, and theatres, etc. We also, for our sins, looked after Wembley Stadium. That's the old Wembley Stadium, which had a CLOTS system installed with 2 fibre optic links, controlled by a Mac computer, touchscreen, so you could control each zone, whether there was delays, etc., etc., etc. And we were there when Madonna did her tour, and we were up there for every football match because none of the concerts, none of the football matches could go ahead because it was the main evacuation system. And the best part is that none of us on the company I worked for liked football, but one of us would be handing out the radio mics, etc., on the etc. From there, I stayed there until I retired, really. Although I did get back into doing a bit of work at a boarding school. But TV-wise, first started off with an article from the BATC, which was how to convert your Pi Westminster, which I did do, and put some AM modulation on it. And talked to a friend of mine in Brighton, day in, day out. And then we decided to get into putting a repeater on, which we put on at his place. And then progressed on from there. We managed to get a site in Brighton, right up at the race hill. And we had a 2-metre repeater, a 70 SEM repeater, a 23 SEM repeater, a 2.4 repeater, 10 gig repeater, with a digital output at that time, which was done by an encoder, a commercial encoder. There was also packet involved, so it was a busy site. From there, I was also involved in the Worthing video repeater group, which we ran, which we sold the transmitter and kits, etc. Used to maintain those. Was involved in the TV repeaters, and my philosophy was just do it, basically. My knowledge on the programming side of things is virtually zero, which will explain why I've done the Allstar in the way in which I've done it when we get to it. Anyway, right. I've got a picture up which shows my shack, which I was just going to say. Well, there it comes. That was it this morning. It's in the corner of the lounge, which you might have seen my wife disappear behind me just now. But that's it. Not many monitors. The one on the right is a ride receiver, which is what I was monitoring things this morning, and I've got a laptop to my left, and another little screen which is looking at the node. But probably time that we moved on. I just thought I'd give an insight to when someone sees me on, I'm usually known as the King of England, being the call sign. So we'll move on to the first thing. We'll make that a bit bigger because all my pictures need expanding. Why Allstar for BATC Talkback? Well, I started off trying to use DMR on the Brandmaster network using talk group 144750. This proved to be not very successful, shall we say, because a lot of people aren't used to programming up DMR radios, plus if they're trying to use a repeater to actually link to it, and the audio quality can be a lot to be desired, shall we say. It's an acquired taste, and compared to Allstar, there's just no comparison. So I moved over to creating a node on Allstar for Talkback, and one of the advantages with Allstar, which people may or may not know, is it's a peer-to-peer system. So you set up your little node, which can be anywhere, and you connect to it by whatever means you want. I'll run through some of the different means that you can actually connect to Allstar via your node. But your node can then connect to any other node. You register, get a number, but we'll sort of half cover that a little bit later on. So you've got your number, you can dial it up and connect. I probably ought to go on the next slide because I think that's probably, I say slide, next picture. The early, the Hamvoid is the place to go to get the original software, which works exceedingly well. There are various set up videos, etc., to cover, and there's lots of useful information on the how-tos. There's a how-to one in the center there under the donate sort of thing. If you go there, how to set up a 888 hotspot, how to use this 818, how to make a radialess node, and so it goes on. But the setting up of Hamvoid images is not difficult, but it's not as easy, and it's been around for some time. It's very versatile, and those that are into Linux will think it's lovely. I'm not. I struggle a big time. As I said to David when he was quizzing me last night on doing it, that I'm dyslexic, which doesn't help. So if you put numbers in the wrong way round, or letters and things, and wonder why it doesn't work, which is why I tend to cut and paste wherever I can. The Raspberry Pi I hate, though I've got 9 of them last time I counted. So they have their place and they do work exceedingly well, but I don't find them fun to play with. Yeah, I think we'll move on to the next one. I can't remember what the next picture is. It's right. ASL features. ASL3 is the later software that's starting to be developed. It's in its early days, but it is much easier to set up. So as a newcomer, I would go for ASL3. If you're an existing user, you might say Hamvoid is the place to be, and I can do all this and I can do that and I can do lots of other things, which you certainly can. With ASL3, you can use it as a fully featured, as it says, controller. It's voice over IP, but the other interesting thing, full duplex you can run. Like my radialess node has a speaker in it and a microphone connected to it, and I can run it full duplex. So you could hear if anybody else comes up. And the quality being FM is superb. Simple half duplex station, auto patch reverse, frequency. You can read it yourself. Based on the Ascaris open source PBX system, basically a phone system, with all the ins and outs that can be done. It is very, very versatile. It's, if you know what you're doing, which I don't, I'm just a person that's looked at lots of videos, gone down lots of rabbit holes, started from square one many times, but it once you get to grips with it, it's really, really good, I think, anyway. And right, getting started with ASL3, you basically download the image file. Now, that's assuming you've got a node number. You've got to have gone off and registered it. I may have this in, I think I've probably got the site later on, but you need to have got a node number. So you'll have a node number and a password and an IAX, not an IAX, a port, IX port number. So you download your image for the Pi, and the crucial thing is to use this to actually burn your image. Well, I say it's probably those that know what they're doing can do it another way, but this, so you choose your device, which is nice and easy, whether it could be a Pi 5, a Pi 3 is sufficient, and everybody's got a Pi 3 or usually sitting around doing nothing. I certainly did, and I've managed to make use of my Pi 3, which for a while I had a Pi 4 in use, but I've reverted back to my main node to a Pi 3, and the Pi 4 is now used on my ride. I see there's a little me in the corner. So right, you choose your device, you choose your operating system, which is what you've downloaded from the website, the image. Once you've done that, you go to next, and then there's I can't think what it's called. There's an other settings as such, so you can actually then set up your node number, the IX port, etc., and your Wi-Fi. All mine are connected via Wi-Fi, so you can set your Wi-Fi up, and you burn the image basically, and it's all then set up to get started. Right, let's go to the next one. Welcome to Allstar Link. Why did I put that there? Probably to remind me that it's Allstar Link, ASL3. A lot of this is done to remind me as much as anything. I didn't have a chance to rehearse anything, get it in order, and this is the first presentation I've ever done of this sort. My main operation is via QO100.
You're doing really well, honestly, Martin.
Okay, right. This is a sort of, to highlight the peer-to-peer side of things. The node that I've set up is 47572. This, I think I did a grab yesterday. And you can see I'm connected via my Sun Radio node. Why is it called Sun Radio? In my dodgy days as a youngster, I used 813s and 2.5 kV on the anode and a rather large transformer. Anybody that's heard of GWM radio in the South Coast when it was available, that's where all the bits of kit came from. And yeah, we'll leave it at there. You can work out what I was doing. And as you can see, one station I want to highlight is G1 OAR. He's built his own node using the 888, and he's done a wonderful job. I think it's Peter. I was going to mention him later, but I'll mention him now, seeing him is on the I can't think what you call it now, spider, whatever. It'll come to me in a minute, but you can select these at any time from the various things. But as you can see, Mike's connected to it. Martin G4FKK, and so we go on. But the advantage with the system is they're all connected to me now, but two of you could decide, let's say Martin and Mike wanted to have a conversation with someone. They could disconnect from me and connect directly to themselves and carry on a conversation without affecting the rest of us, a little private conversation. It's totally flexible in that respect. So it's what your imagination is. Now, a node. What is a node? Can you build your own node? This is one I built ages ago. I mean ages ago. I used to be involved in some local repeaters down here. And we had Allstar, we had DMR, we had Fusion, but you can't sort of, the quality, the easy for the ears, particularly as you get older, to listen. Now, the key things to it is obviously the Raspberry Pi. This one's connected onto the network, and the CM108 sound fob. There's two connections to it, and you can see in the corners. I think I could make it even bigger to highlight that, perhaps. Those two wires to connect. Those are probably the trickiest bits to do. But it's not as difficult as it first looks. I struggled to start with, but it's ever so easy. Providing you've tinned it up, got your piece of wire ready, it's nice thin stuff, bang, bang, it's there and you're away. One is COS and one is PTT. So the PTT one wanders off. I think between this blob at the end here is a transistor. I think that's what I put. So it just literally grounds and puts the 888 Bofang, which is what this is, into transmit. The COS, which comes off of a chip that's underneath, and I fed it through a diode to isolate it, and that comes back as a bit of protection. Now the other, I fed the Bofang with actually it's a 5-volt regulator, which comes off the main inside 12 volts, and then through some diodes to drop the rest of it down to 3 point something or other. On the supply to the Raspberry Pi, I've gone straight on the header there. GPIO pins on the power at the end. That can present some problems when you have problems, but I'll mention that later. But this has worked for years. The other thing is using the buck converter. If you stick a scope on the end, you find it looks horrendous. Put a choke of some sort in and a capacitor. And it's not too critical, and you'll find these nasty spikes disappear or are greatly reduced, shall we say. The Raspberry Pi is inherent in producing lots of nasty spikes. Another key point, which is this earthing point from the main radio to here. I can't take credit for that. It was G7RPG, who a lot of people have heard about, who produces nodes. You can buy them ready built from him on this sort of system. He spent ages chasing things down. His looks a lot neater than mine. The other mod to the 888 is taking out the PA transistor and linking it across. That's providing you remove the choke little coil that's feeding volts to it. That then reduces the power because you don't need power, and you can just about see an aerial at the top, little springy aerial, and that is fine. This node at the moment is in the cupboard behind me, and is connected to the VK network, and actually has 2 nodes on it, one a radio node and one just a sitting there as a hub as such, or whatever you want to use it for. You can put on one Raspberry Pi a number of nodes. One I did have 2 cards connected to it. It's endless. It's down to you what you want to do as such. Right, let's go on to the next bit. Now, a radialess node. How can I do that? Now, this is the simplest. Is the sound fob. Okay, you've got to plug it into the Raspberry Pi. And it's got the 2 wires on it. Now, the thing here is that the PTT, which feeds off and let's make sure I get the right way around. It's sort of, anyway, the PTT becomes, I mean, let's get it the other way around. The COS, which is carrier detect really, becomes the PTT. So you ground that on a radialess node. And the other one you can feed to a little red LED, and it'll tell you when the unit is actually receiving signals. Don't have to, you could just connect them on wire. I've just picked it off at this point here because there's 5 volts sitting on that nice capacitor there. There's lots of mods you can do if you want to mod the actual fob, but I've just left it as it is this instance. And you've got audio and a microphone plugged into it. And that's it. The audio goes off. In this case, it went off to a little amplifier. You can't get any simpler than that. So you can get on doing something like that. Let's go on to the next one. Now, since then, I've put it in a box. Basically, it's the same sort of thing, but there's a little amplifier module that's sitting behind the red, and there's the little LED there, and a microphone. Now, the microphone has a large electret in it, and I seem to get just about enough gain if I talk into the hole which I've enlarged. I didn't want to put an extra amplifier in. You can get, there's always inherent buzzy problems that you can get. It's a plague and a nightmare, but that I use, and it's ideal because I can just sit there and monitor. I'll use it as a test bed or whatever. I can listen to myself coming back. Now, the node that I'm using is a Shari type node. It's based on the SA818, which is not the cleanest of devices, but it's very convenient to use. And that has the sound card effectively on it, etc. So you don't have to do any nasty soldering on, and it plugs just into the Raspberry Pi. Now, as you can notice, the way in which this one is set, if you plugged it into a Pi 4, you wouldn't be able to get to the network side of things. Now, some people have extended it, the actual leads, so as they can actually get to it. When I was running this on a Pi 4, using the ASL3 setup procedure meant you could set up the Wi-Fi, so it didn't present a problem. That's one of the niceties about it. So I could plug that directly in, and that's I didn't have my other picture, but that's what I've done with it now. So I put it in a box, which just makes it reasonably neat. Pi 3, and the node plugged directly into it on the USB side, and a nice tidy bench. And that's what it looks like when finished. Right. go to, now, let's enlarge this. Now, it's not a good picture because I nicked it, I must admit, off the Shari website information. And one of the important things they say is to put one of the clip-on ferrite devices with a couple of links through it to get rid of the nastiness that tends to come from the plug top power supply. That helps. I won't say it totally cures things, but it's worth having if you're using a plugged up power supply. It will make, I've done things different since then, just by trial and error, really, more than anything else. All my things, I try something, just because someone says you do it this way. Anyway, that's my node at the moment. Now, as you can see, I've put a low pass filter module on the top of it. That has made the world of difference for me. It's cleaned things up quite considerably. The black box beside it has a large buck converter in it, one that you get off of eBay in a tin plate. I think there might be a picture coming up of it in a minute. And that comes off of my linear power supply. Now, I've found that if you can use a linear power supply, it seems to make the world of difference. I was getting all sorts of problems initially, that lots of buzzes, etc. And it all depended whether you put a resonant aerial on. A resonant aerial cleaned things up no end. But you were still, and it's an inherent problem with nodes in general, that there is peaks and nulls as you move from it. So you get nasty buzzes, etc. But for me, the low pass filter, which I bent a little cover to put on it, but I bent it slightly wrong because it was supposed to go over the complete board. But I'd forgotten about the bent, and what I used was a bit on the thick side. The other Martin told me there's a whole art to bending things, but I didn't get it right. But anyway, I can now put almost, I've got actually a larger aerial than that on it now. And the buzzes seem to be pretty well non-existent. You get some little peaks and lows, which you'd expect as you moved around. But I can thoroughly recommend going that route. Initially, when I was first trying it, I had the Shari node that I connected, and I was doing all sorts of different power supply trying it, and I fed the Raspberry Pi off a buck converter, and I thought maybe that's the way to go, and I was feeding it from a 12-watt supply I had. Unfortunately, the buck converter decided to do something nasty, and it killed the Raspberry Pi. And I was thinking, wow, have I killed but I hadn't killed the interface, which, anyway, just something to bear in mind. Get a nice, I think, linear power supply I would recommend as much as you can. Or now that's the filter I put in on eBay. They seem to work well for me. My little tired eyes, I thought, shall I attempt to build something up or not? And I thought, nah. As you get older, I was born in 1950, so you can work it out for yourself. It's a struggle, but I can recommend those. They're also on the, which I didn't realize at the time until I got it, on the wiki, BATC wiki, to clean things up. So someone else had probably found it. Oh, right. Now that's the buck converter that I used in that black box that was alongside my node. As you can see, it's quite, I think it's capable of something like 10 amps or whatever. But anyway, that seems to work well in its little box. And I've used them in a number of applications that I've got here. So that's where I would go. Right, what have we got next? It's almost a surprise for me as well. Right, now the ASL3 You've downloaded it, you've installed it, and your Raspberry Pi has gone beep. Now, don't rush at that point to key up your radio and do anything. Go and have a cup of tea. That would be my biggest thing. It seems to do lots of sort of housekeeping and other bits and pieces at that point. I've made the mistake of rushing in too quickly, and you find things don't actually work as they should. So that would be my big. So you've got that. So you've got 3 options there, and you can. First off, you need to go into the web admin portal. Sounds really posh. This is known as the cockpit. Let's go to the next one and sign in. Now you've set that up earlier on when you did your image. So you put your username and password in, and we move on into what you get. Once in, you've got loads of options. I'm not going to run through them all, but you've got an overview, which is what it's showing there, and it'll tell you whether the system's up to date. If it's not up to date, which usually I've found that even if it says it's up to date, I'd almost reboot the system and go into it again. I don't know whether it doesn't always quite finish setting things up at that point, but if it's not up to date, go down to the bottom and click software updates, do updates, and again, if that software updates say, oh, I'm not working or whatever, just reboot the system or whatever, and it'll all sort itself out. Don't be impatient. I think is what I would sort of say there. That's been my findings with it. As I said, the software is in its early days, but it's recompiled on a much later Linux, which again into technical things there, base, and is version phenomenal in comparison. But it is very user friendly, I find anyway. I wasn't sure when I first started, but we've gone. So, right, let's go to the next one. Right, if you go down to terminal, you get an SSH screen, and you need to type in these technical things like sudo dash ASL. Is it ASL? Sudo space ASL dash menu, and that will come the menu. It does actually tell you at the start screen, I'm sure. It says going back to in this text here, it will tell you the asterisk CLR accessible by typing sudo asterisk when they put dash RV. Now, I don't know what dash RV means, but I don't put that in. But anyway, you've got the node setup menu. So the first time you'll go in, you'll need to hit node settings, and there's another node settings. Then it'll come to, and there are various, I'm not going to run through all the things that you set up in there because I will make another suggestion in a minute, which is what I did using other people that know more than me. You've also from there, as your number 6, you can see it's, let's make that bigger, expert configuration menu. From there, you can go in and you can edit the common files, the RPT config, the simple USB, IX RPT, etc., etc. And you've also got on B, backup and restore. Wonderful. You can make once you've got it working, make a backup, and it stores this backup. So if you absolutely messed up your config somewhere, you can restore. That, for me, has got me out of a lot of problems early on. If you really mess everything up, just go back and redo a new card. Burn a new card following the procedures. It doesn't take long. I've done, since I started playing with SL3, because I've made lots of mistakes. And I think I just play with this. Oh, I shouldn't have done that. Oh, it's all in tears and restores. Anyway, that's what I would suggest. I think the next one will come. Yeah, right. So let's assume we've set it all up. And one of the things that you need to set up in there is you need to go back into the SSH side of things, change the directory, and set up the password for the node links. Now, that information, I'll tell you where to get that as well, which you can just copy and paste a couple of lines in, and you put your password in you want it to be to access your node links. So if you're then to click on the node links, you'd get, oh, I've gone to, and I don't want to go to him. Let's go back. This is cheating. Right. I wasn't supposed to see him yet. He's coming in a minute. Node links takes you to something that looks like that. That I grabbed yesterday, which is my node 47572, which I'm hoping is going to be the Talkback node for a while. And it's I'll get the plug in here. I'd like the BATC to take a node on, not necessarily this node, their own node, and set it up on a web-based sort of on a server in the cloud sort of thing, which would be nice and easy, so as people can use that or not use it as a. So that's what I'm pushing for. Interest in Allstar seems to have grown quite considerably. Right. Now, those are all connected to it. If you wanted to disconnect somebody, at the end, you'd find a little cross box that you could click on. I'll make it bigger, but by the 47188 at the top, there'd be a little X. So you could click on that and it would launch instantly another window, which I haven't done grabs of, which has already then put in the things for disconnect. So you then execute, and that would disconnect that person. If you want to connect to somebody from your node, you click on what I call a paperclip, which is this second one in. Well, I've always called it a paperclip, but it's not really a paperclip. I think it's a figure out anyway. It looks like two chains or something. But anyway, if you click on that one, it opens up a window, and you choose at the beginning, connect, and then you type in the node number, like a telephone directory, that you'd want to connect to. And you click execute, and it'll connect, providing they've opened up the IX port on their router. Now, from the software, you can get out to connect to anything, but if you want to connect to somebody, they've got to have opened their port up so as you can come in. So it's just port forwarding, and you forward it to your Raspberry Pi where your node's on. Hope that sort of helps. So that's who was connected yesterday. I could do something really dangerous now, I expect. It says dragging across from, oh, come on. When you try and do anything live, it doesn't want to work for me for some reason. I know why it probably isn't working. It says, no, we're going to ignore that. I was going to drag through another screen, which I've got on another computer, and show what is actually live at the moment. But there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people connected. I might show it at the end if I get brave. But that is really easy to use. It's not as complicated as the Allmon side of things on the earlier software that was originally used, which I said works exceedingly well. Let's go to the next one and see what we come up with. Now, this guy, I have to plug him because Ham Radio Crusader is where you go to find out how you set the software up. His step-by-step instructions, where to register, how to put the password in, etc., etc., etc. It's just absolutely brilliant. He does a number of other videos, but I've not bothered to sort of say this is what you do, that you do, because just go and watch the video. You'll learn so much, and if you make a mistake, you can go back and you can rewatch it and say, oh yeah, I should have done that there. So yes, I'll give it a plug there. I ought to give a plug to right, someone else I expect in a minute. Right, now we get to you set up your node, whatever it is, and you can use a program if you want to called IXRPT. Now the same guy that I pointed to before also does a video, I think, on setting this up, but it's not too difficult. It was difficult. I had great difficulty in getting it to work to start with, because it's a very old program. It runs on a PC, and you can connect to all your nodes that you've set up with the appropriate settings in. So I can call them up, and I can select whatever I want. Like at the moment, I'm connected to the BATC Talkback, and you can use your microphone and speaker on your computer. So that gives you the option there of getting in that way, as well as your radio you can use. So that's on your own network. Now, DV switch. Now, if you've got an Android phone, you can set DV switch up in your node to connect. Now that runs on an Android phone, and if you're internally, you obviously set it to your internal IP address. If you want to access it when you disappear into town or whatever, then you need the IP address of your router, and you need the port forwarding to be put in accordingly to connect to the appropriate Raspberry Pi node that you've got here. That works exceptionally well, and the quality from that is superb. I won't do it. I was going to do it. I could do a live demo, but I won't at the moment. Only for its time at the end. Right. That one was free. If you're one of these people that have got an expensive phone, there is rumours that this works. I don't have the expensive phone. I have only an Android phone. But that apparently, the repeater phone will work. It's not as easy to set up, but apparently will work. I don't know anybody that's used it. I only know that people talk about the fact that you can connect that to your node. But you have to pay for that one, which you don't have to for the other one. Now, Benno. Now, Benno was, I've got to give him a mention. When I first started talking to him about Allstar and such like, he didn't see any point in it really, to that extent. And whatever Benno does, he does at speed. I can't keep up with him. He's got a lot of time for Benno. He obviously runs the shop abroad, the European shop. But he's produced this board. Well, he's producing this board. This is the first prototype that he's shown pictures of, which has the sound chip on it, sound card chip, and all the interface bits and pieces, so as you can connect it up to your radio, a Bofang radio, say for instance, without needing to do any mods to it. You just plug it in, etc., etc. You've got to just connect it to a Raspberry Pi or something. It's in development, but PA3 FBX, brilliant. He rushed off and got a, to start with, a Shari node, which is what I would recommend if someone doesn't want to build anything. They come, the instructions are good, and they look something like that. Come in a nice little box. They do various versions of it. They do even one for Pi 5 if you want to go that route. But you don't need, probably if I was buying one, I'd buy a Pi 4, put it in, but or put it on a Pi 4. But Pi 3 is quite happy, but it's just that the Pi 4 is a bit later, and probably easier to get hold of, and will be easier to get hold of for longer. I don't know what we've got next. Now, yes, this is my other plug. This is what's sitting underneath my router. You know, you sort of think of I'm running a node, and it's something big and complicated, and that's it. It's a Raspberry Pi 3 connected Wi-Fi wires, a plugged-up power supply, and that's what everybody's connected to. That's connecting to 47572. I just had to sort of show that. What's the time doing? Right, I think that might be the last slide, but I'm not sure. Well, yep, that is actually the last slide. So I think I'd probably, unless I could fill in with do demonstrations. I wonder if I can actually get this to.
Well, Martin, we have actually got some questions and things for you as well. So
yeah.
I think it might be a time for that. And then we've got time at the end of that. Then
Yeah,
maybe
no,
we
you go for it.
I must say here, and I won't be the only one here, and literally we contacted you, I think, late yesterday afternoon. And to just put this together and do that, I thought I was going to be asking you questions and everything. I did a bit of homework on it. You haven't needed it. It's a brilliant presentation. Thank you so much for all the work. You must have put in some midnight hours, I think, into that. So thank you for that. And we do have some questions for you. But if you haven't already done so and you want to ask some questions or make some comments about what Martin has done, this is the time to do it, because we are running to a schedule today. Now, the first question that I saw come in, let me go back. It came from Noel. And it is, and they've had quite a few since. So here we go. Question 1. Is it peer-to-peer only, or is there multicast? Whoops, it's just gone. There's quite a few coming in now. Here we go. Where are we? Sorry about that. That's one of the... Is it peer-to-peer only, or is there multicast, broadcast to many mode?
Right. Now, the node that I set up is a standalone node, but on average, I think there is a limit, but I don't exactly know what the limit is, but something like 25 people can connect to that one. So they can all connect at the same time and all chat. And if they all had duplex side of things, then you'd be able to have a telephone type conversation. If that makes sense. I think that answers what Noel was asking. It's down to you how you set it up to how you want it to function. But yes, it's individual nodes that you can connect up however you like. One can be the hub. If you look at the, I'll give a plug for the VK network, which I can't remember the link to, but I have it on my little thing. Theirs is a vast network of repeaters out in Australia, and it works exceedingly well. Now, theirs has a lot of other networks connected to it. I'm not in favour of having any other network connected to it. That includes some... I did a repeater, as a revolving repeater that had multiple modes connected to it, and it just doesn't work. So way I would stick, including not having Echolink, because Allstar has the facility of having Echolink. I wouldn't put Echolink on it. I would just have it. You have your own node, and you connect to the hub, whatever the hub is, and that will, as many stations as want to connect to it. If you exceeded the limit, then you could link that to a second node, or second hub, shall we say. To share the load, because if you look at some of the large networks, they'll have a big spider arrangement that's connected. Anyway, that's probably a long waffle.
No, that's all right. Thank you very much. There's also been a few answers on the chat, but it's good to do it here because some people are watching on YouTube and some people are watching on BATC. So that's why I always read the questions, even if someone has answered it online. G6HFS, by the way, says, got my Allstar node number this morning. So there's someone else who'll be on the system very soon. Noel has got a part 2 question for you. As per my post on the forum, can it run over the 70 SEMS DMR repeater network? If not, it's a non-starter for portable stations, as it's hard, almost impossible, to get a reliable 4G connection on hilltops. Have you thoughts on that?
My thought is that it's independent. I would keep it independent because of the quality. The DMR is not good. Providing you can have a node somewhere that you can connect to from whatever hilltop it is, whether you've got a friend or something that can have one on. I don't see, repeaters. I can see repeaters could have their own nodes, etc. It's all down to it. But I know Noel's anti it because of DMR. I'm anti it because of DMR, having had the experience of playing with DMR and the quality. But my main thing for setting it up was for QO100, which I hadn't really sort of mentioned, as a talkback channel. When you're actually operating through, it's so easy to, in particular OBS, to move from one scene to another, and you haven't enabled the microphone. So you're busily chatting away and nobody can hear a word you're saying. So the idea of the talkback in that instance was so as someone could key up and say, hey, your mic's not working, which happened to be on the last BATC net. So I think Noel and I probably will be in different directions on that. So, but anyway.
It's funny that someone actually put on a little while ago that I could have done with this morning talking to Michael, couldn't I? Ironically, at the end of his talk. I've got another question for you now. It is from, let me see, there's quite a few coming in now. Ron, G8DVR. If I register with Allstar, can I access from my Echolink node using no radio? Now, I know you said you didn't recommend Echolink, but what do you think?
Right. You can put Echolink, you've got to install it on your node. And it's Echolink is Echolink. So, yeah, if you can connect to the Echolink network, then you can connect to that. If you want an example of it, then HubNet has Echolink connected to it. It also has DMR. It also has, but they've got bridges involved. And when you put bridges in, you get delays, different delays, and the quality of the whole network tends to be degraded to the worst common denominator. I think that makes sense.
So it kind of brings everything down then, does it?
Yes, yes.
Right, so that probably isn't something you'd recommend, but...
I don't recommend it.
But it can be done.
It can be done, yes.
All right, well, thanks for the qualifying it. Dave M5TXJ says, I use Zoipa to connect to a remote IAX system. Could this connect to a remote BATC node? And as a part 2 to that, he explains that Zoipa is a VoIP app on Android that dials in to an IAX server in the cloud. Are you familiar with that?
Vaguely, I've never used it. I think, again, the Commander guy, I think, did do a video on that. But if it's an IAX side of things, then the little app, the IX RPT app that I had on the PC, that's the way it's connecting into it. So it'd be how you configured it in the config, basically.
Okay, thank you. Actually, talking of Michael EA7KIR, he says, I can see myself re-watching this talk many times, so thank you, Martin. Lots of people as well, by the way, saying thank you very much. I can't read everybody's question out, but comment and compliments out, but you'll be able to see them yourself. Another question now from Dave. That's all I've got, I'm afraid. My local repeater has Allstar. How do I use this to connect to an ATV hub? Would this annoy the other users? I don't have 4G where I go out.
I don't know. It depends on the users of the. If you can actually are able to, your nodes that you've got have their own, I was going to say telephone number, effectively node number. And if you're able to dial in a node, you can use DTMF commands usually on phase repeaters, but it may be restricted on that particular repeater. My really suggestion would be to build your own node, even a radioless one, if nothing else. Repeater users can get back to you from JK.
It's all right. There's so much to discuss with this, and do you know what I must say, as someone who doesn't get time to make much stuff in my life, but runs a busy club in Norfolk, it's lovely to see that everything so far today has all been all about making stuff, because I think many in the amateur radio community now just buy the boxes and they work and that's it. So it's lovely to see all these projects and things coming together. G0MJW Mike says this is on the basis, the first part is, my idea for portable is to have set up nodes where you can reach with an FM handheld, e.g. based at a DATV repeater site. And part 2 of that, this is on the basis hopefully DATV repeaters users won't be upset by people using them for DATV talkback. Any thoughts on that?
Yeah, totally agree with Mike on that one. This is where it's totally flexible on, if you had a TV repeater that was set up with its own node, it's so. Plus, you can have your node set up at a friend's place. If you've got another amateur, if you can set a node up there that you can access from wherever top you are, or if you really if you had another vehicle that you could park just down the hill a little bit, that you could, where there was some phone coverage, you could then access that. I don't know. It's the imagination is down to you, the user, really.
What you do with it, yeah.
Yeah.
Fantastic. Martin, what can I say? So many compliments as well on there, and it literally was last night that you agreed to do this, and it's wonderful that you did it. I hope you don't mind me saying, you'd never even used Zoom before and installed that, and we went through a quick rehearsal last night. So it's fantastic that you've taken us on board. Really interesting stuff. Thank you so much on behalf of everybody at CAT24.
Yeah, no, please do it. I panicked this morning when I was trying to sign in that I was doing things slightly wrong. I thought, I don't want to be late.
No, you were fine. It's all gone swimmingly. Thank you ever so much, Martin.
7 threes.
Cheers. There we are. Now, at the RSGB convention a couple of weeks ago, Noel G8GTZ came and looked at the live stream studio that we'd rigged in Milton Keynes at the RSGB convention, and he thought that a behind-the-scenes look at our studio here might interest you during lunchtime in this CAT24 Part 2. So, although we use a different range of equipment here, we're now going to rearrange a few things and then reveal how we produce this event for the BATC, giving you some behind-the-scenes looks, as well as showing you a couple of other pieces of equipment which we use for larger outside events at our local radio club and for the RSGB. So why not grab a coffee and a sandwich, and we'll join you in a couple of minutes. So welcome back to the live stream studio here at CAT24. Now, as I said a moment ago, we're going to just show you behind the scenes. This is very impromptu, I can tell you. There's nothing rehearsed about this really at all. We have, though, had to rig up a couple of extra cameras so that you can see things that otherwise you wouldn't see. Normally you just see me on this single camera. The first thing, though, I need to do is to tell you that this is a team effort here. It's not just me, but my wife, Tammy, M0TC, is next to me, and we can see her now.
Hello.
So there we are. That's now we do use this wide shot sometimes for our club event, and we won't take too long to tell you this, but basically until the pandemic, neither of us had done this together. We never worked together. Many years ago, I'd worked a bit in broadcasting at the BBC as a freelance, although my main job was running an electronics business for 40 years, but never touched it. And since we got married, we'd never done anything like this at all. But when the pandemic came, we thought that, I as chairman of the Norfolk Amateur Radio Club, realised that we were going to have to do something to keep the club together, because our club met every Wednesday night and before the pandemic, and once that word lockdown was used, I realised that we needed to do something. And because I'd always been interested in television ever since a kid of 8 or so, just been fascinated with it, I had quite a bit of ATV gear, and I could kind of put those skills together, learnt a little bit about streaming, and within a few days we managed to put something on, didn't we? And Tammy, you'd never done any of this sort of thing.
No.
You started as a real rookie, but
Yep.
I think it's fair to say now that Tammy knows as much about it, in fact more about using the equipment, and certainly using it adeptly than I do. So although you may have seen CAT24 before, CAT conventions before, or any other of the productions that we do for the RSGB, like Tonight at 8, or their AGMs and things which we stream, this lady here is next to me all the time, pushing all the buttons and doing a lot of the mixing. And we're going to now give you a behind the scenes sort of tour of that, very impromptu. But if at any time during it, because it's not going to be like a formal presentation, you want to ask any questions, we're very happy to answer them. We'll try and keep an eye on the chat, and you'll see how we see your questions coming in. There's nothing magical about it really. We've just got several computers in here. So we're going to take you through everything bit by bit. So as I said, we've added a couple of cameras in here. Normally these two cameras which we're talking to you now on, they're just basic camcorders, because that's how it was a few years ago when we didn't really know we were going to do this. So we put into action a couple of Panasonic camcorders and connected them into a video mixer. It has evolved over those few years, I have to say, and we've bought a lot more equipment now. I keep being told by my wife, you bought something else, that sort of thing. But we've also added today a couple of other cameras. So, oh yes, Tammy's there, used one of the PTZs there to show the cameras. So there's the couple of Panasonic cameras. One's doing a wide shot. The one in the middle, the one on the left there, is doing the shot that you were looking at a minute ago. And the one on the right there is in front of me. And in fact, Tammy, can you pull right back, and then you can get some context, I suppose, of how this is. So this is a room which we've now dedicated to a studio. When COVID first came, and you can see me chatting, I'll just wave there so you can see this is live. When COVID first hit, we hadn't got any of this set up, and we just used a conference room in our office, our workplace actually, to set this sort of thing up temporarily. But as things got back to normal and staff kept coming in, started coming back in, we had to do something different. So we moved it fairly intactly into this fairly compact room, and there's quite a bit of stuff here as well. We're going to take you through that now. So we've talked a bit about the two cameras. We might have, if we've got time, talk to you a little bit about the PTZ as well, that we're using here, because there's quite a nice feature on one of them that we've got recently. But we'll start with that, and I think the next thing to do is to tell you what happens to the signals from the cameras, which they go into a mixer.
They do.
So Tammy, do you want to talk about your favourite mixer here?
I can. Let me just zoom in. I won't make everybody sick by going real quick. So this is our...
So this is a Roland V8 HD. If you're interested, we wouldn't normally tell our audience this, but this is what this is. Very compact. It's an HDMI mixer, which is not what we use for some of our bigger events outside, but it's very compact, built-in preview screen, 8 HDMI inputs, and it's a sort of, if you're familiar with switchers, you know, you can use it in two different ways. This is an AB switcher, so that you can use it for what's called now and next. So if you have a look at that, for example, you can see the red button 4 is lit up red. And that means that is the live shot that we're using from camera 4 at the moment. This is say rigged differently for today, just so that we can show you behind the scenes. And the 2 there, the second row, the bottom row, would be next. It's number 2. And that, if Tammy pulled the fader down, let's just do that, Tammy, just to show what would happen. It will bring you to camera 2, which is this wide shot that you've got of both of us. But we can go back to that. And then I'm going to let Tammy tell you more about what this clever little box can do, and not just me, because you know it much better than I do now.
I do, yeah. It's so we've got presets along the top here. These are for different things. So in this particular mode at the moment, you can probably see my cheat sheet here. So basically, if I press 1, it's a double head of me and David. 2 is the double that we use when we're talking to a speaker. It automatically takes channel 8 to put it onto the back.
So that's when we've got a remote speaker, isn't it, coming in on Zoom, which we haven't talked about yet, but we will do. Yes.
Martin.
So that double-headed shot at the end.
Yeah. This one will just go straight to the guest, which is on channel 5. The guest is always on channel 5. And then 4 is your camera, so it'll go straight to you. And then obviously 6 is the guest's Zoom presentation normally. And then we have another one, another double headshot here, which just has white banners around the edge rather than red ones. We have 2 picture-in-pictures, so these controls here is 1 picture-in-picture, and these controls here are 2 picture-in-picture, and I can pick which input I want to be on the picture-in-picture. So at the moment, if I just put on the preview, I can see that's David's head, so I'll put that on the screen now. And the picture-in-picture is good because it's come up automatically that size, but I can make that smaller. If I actually pull that across the other side, you can see what I'm doing here. So on this button here, if I push it down, I can make that picture-in-picture smaller. And then the other side, if I push it down, I can actually zoom in. So I can zoom in on a picture-in-picture. And then without pushing them down, I can move it around. So I can basically put the picture-in-picture at any point on the screen. When we've got so many slides on, I can find where there isn't a space and move the picture-in-picture to go there. I don't normally move it like this when we're live. We have a preview, so on a preview screen I can preview to see where it is and where it's going to look, and then I can make it go live.
One of the nice things that, and thanks Tammy for that, some of you may be familiar with Blackmagic, which we've actually invested quite heavily in that for our outside broadcasts and things, and it's lovely equipment. But one of the things that Blackmagic does, a lot of it is software-based control, and particularly picture-in-picture, or sometimes called SuperSource with Blackmagic, is it's all set up with a computer. One of the wonderful things about this is it literally has 2 physical controls. So Tammy can do this very quickly on the fly. You can just see on the preview monitor there.
Put you there on the
and you can move that around, and it is really very, very quick to respond. Someone actually made a comment this morning. Again, we can share this with you. Someone asked, why is there a red banner around a slide? I can't remember whose slide it was.
Yeah, it was Dave's
Dave, wasn't it?
slides at the beginning. So basically, Dave's slides coming into our mixer weren't quite full screen. So what I actually did was I used the picture-in-picture screen that you can see on the screen here now with David's picture. I actually used that, and I used the zoom function so I could make it larger so it would be full screen, which is why they just happened to be a red banner around, because I used that particular.
We did it very quickly, didn't we?
We did it very quickly.
And this is the technical reason is because Dave's monitor was much larger than his the window that he was sharing, and we're taking this is a standard HD signal, so 1920 by 1080 is what we need. And this is we're just trying to explain really the flexibility of this mixer to be able to do that very, very quickly on the fly is very useful. With the ATEM range from Blackmagic and a lot of other ones where you set them all by software, there's just not, they take a lot longer to get that right. So that's one of the reasons you like this, isn't it?
Yeah, it is.
We've talked about pictures so far, and so there's the mixer. It does have some basic audio mixing, I think, Tammy, but we don't ever use that feature, do we, really? No, we've got a separate mixer.
We've got a separate audio mixer. If I just come back to there for a moment, what I'll do is I'll move the camera so I don't make everybody sick. I'm in the way at the moment.
So we can see a preview picture here. And this is now a pretty standard audio mixer, Behringer, they make a lot of mixers from quite low-end ones for 20, 30 quid, almost upwards, up to thousands. Their X32 range and things like that. But we're using this as a basic mixer. to mix audio, to again have complete control on it separately. So in this studio now, both of us are wearing a lapel microphone. We also have a spare microphone, a good old SM58 on a stand, just in case one of our lapel mics goes down, or mine in particular, because I do the talking on most of the things that we do. And we can mix in other things as well. So
yeah,
we're playing
so we've got channel
music.
1 and 2 here are our microphones. Channel 3 is the spare microphone. Channel 4 is actually linked to the computer that we're doing the countdown timers on. So the music that you're hearing with the countdown timers, that's what that one's for. This next one is, I'm not actually using today. This is linked to what we call our caption Mac, which is where we quite often play videos from. And then the one at the end here is our Zoom. So this is, we're bringing the audio in from the Zoom on a computer through the mixer. That's what all those are.
Yeah, thank you, Tammy, for that, talking about that. Well, there's also something else that we should talk about. While we're talking about sound, I will just implore with you all as well, as we're all fellow TV enthusiasts, I think. Sound is often one of those things nowadays that is much underrated and not considered, because you can do wonderful things with cameras, you can do wonderful things with phones now, let's face it, in terms of pictures, but sound is one of those things that often gets neglected. And Michael, who was a sound engineer, as you heard, I'm sure he'd agree with me that many times you see fantastic videos on YouTube, really good quality videos with great mixing and effects and everything, but the sound can be lousy. So it's always worth paying attention, and we find that having a separate audio mixer really makes that work, because you can do whatever you like then. You're not just going to be reliant on what your vision mixer or switcher does. So that's one of the reasons that we do that. We should now start talking probably about computers, and if we start, Tammy, I think we should just start with Zoom. So many of the productions that we do for people, well, nearly all of them, involve bringing in a guest or many guests remotely, and we do use the Zoom platform. Zoom is really good, actually. We find it's good quality and relatively easy to set up, and relatively easy for people to learn if they haven't used it before. But there's one particular extra nice feature on it, which I'm going to share with you now, because some of you may be using this as an idea that may be something you could do with your clubs or other organisations. And that is that Zoom is capable of sending out 2 separate video channels from one call from one guest. And what that really means for us is that when we have someone, say, doing a talk, they could be using a laptop with the built-in camera, and then they're sharing, say, a slide deck on something like PowerPoint. Well, because of the way Zoom works, if you have a computer at the other end or our end with 2 separate, completely separate video cards, we can receive that from Zoom as 2 separate video images. So we've got a special video card connected to a Mac here. I mean, Tammy can just quickly show you, it won't mean much to you, but we'll just show you the laptop that we use for our guests. So this is where Michael and then Martin were going to be in a few minutes ago. We could just show you this, I think, now. Tammy's just doing it. And this is just a standard. We are a Mac family, I'm afraid, so most of our equipment, or all of our PCs and equipment are Macs. And this is the one we use for Zoom. But the special thing about it, this output here is a dual USB-C Thunderbolt connection, and that's going to a little video card at the back of this desk. And that's got 2 HDMI outputs. So, and one of those is the person who's speaking and their picture of their face, as you expect to see, and the other video output is the slides that they're sharing. And the benefit of that is, if you have a setup like ours where you've got a video mixer or a switcher where you can take control of those things, and you saw the way that Tammy could manipulate where a picture in picture might be, or whether it's on the screen at all, if it's going to obliterate and go in front of a slide, for example, Tammy can switch that on and off. It's a great advantage. And when we were told about this, actually, with our friends at CamHams in Cambridge, they told us of this feature of Zoom. I don't think a lot of us would have heard about Zoom even 5 years ago now, but it was used a lot, especially through the pandemic, and has made a name for itself. That's one of the reasons we prefer it. So when we have a guest, we can we have the picture coming from their camera, and then we have a separate picture coming out from their computer shared screen. It does give us a lot of control here to make it into hopefully a good production for people. So that's one of the reasons that we talked about. We better talk about some of the other computers that we've got here, Tammy, haven't we? Because how many are we using today? 6, I think, aren't we? I believe.
Yeah. We've got
So
6 computers.
do you want to
in
take over and talk about some of the other, what all these computers are for? We could talk about the streaming maybe, or what would you like
there.
to do
we
first?
can do. If I go to this wide shot, you can see almost all of the computers, so we can just point. Okay, so the computer right at the end there, that is basically all that is doing is that is streaming to BATC.
We're using OBS, which many of you will know.
Yeah.
But we're only using OBS for its streaming engine, basically. We're not using it for all of the other features you can. If you've used the OBS, which is free, incidentally, you can use it to switch in and out and use it as a switcher, basically. If you've got sources coming into the computer from USB, different cameras and things like that, you can use it as a basic switcher, and it's really very powerful, and it's completely free. But we just use it as a streaming engine. So this is what's actually streaming to BATC today. So all of the pictures, if you're watching this on BATC now, that's where it's coming in from. That's what that computer's for, and because it uses a fair bit of resource of the computer, we prefer to keep a computer dedicated for that, because especially when you've got lots of moving pictures, it's working quite hard, and it's important to make sure that the computer isn't doing too much, especially if it's doing other things as well.
We do also record, so we have
True,
a hard
yeah.
copy of recording of what we're putting out, which we also do on that computer.
Yes,
as
very
well
good point.
through OBS. It's recorded through OBS. We also, on that one, we're monitoring YouTube, so any of your comments on YouTube, we've got on the left-hand side of the screen there.
Yes, so here we've just set up a viewing window just for comments on YouTube, and that helps me if I'm moderating something live. So I've got some comments here from YouTube, and then we might as well now show the next computer, I guess.
Well, this obviously is the next computer. This is the Zoom Mac
one
that
which
we've
we
just talked about.
Yep.
This one in the middle here, we've got the BATC stream on here, and again we're monitoring your comments from BATC. When we do things for our club, we stream to Facebook Live, so we also have that on here. But when we do YouTube, we have it on that one over there. So that's what this one is doing.
Can I mention something else that it's doing at the same time?
Oh, sure, yeah.
So but with something, a production like this, that's quite important to prepare. That's basically one of the things that takes a lot of time for us. And we do have, sometimes it's a scripted, sometimes it's like an audio cue and I read every word, sometimes it's just prompts. So for me at the moment, Tammy, if we could just show that again, I want to show the other job that computer. Can we just go to the wide shot again, please?
I've seen.
Oh, right. So then I've set up a computer monitor here. This is I think a 10-inch monitor. I made this a few years ago, made a bracket for it to sit under the camera. And here I can put notes. So, for example, for doing this talk now, I've got notes on here to try and do this in a sensible order. So we've got cameras, mixer, remote guest and things like that. So for me, it's just slightly off camera. It's not a true auto cue, because a true auto cue would be in front of the lens, actually, and using an angled lens. But I find this is just really useful. And I can select also what appears on here. I can actually have program out. So if I'm talking to a guest, it's quite nice to be able to see them sometimes. So just off camera, as it were, just under the lens, to have a monitor like this is really useful. And I think you'll notice if you go into a modern studio now, or you ever see behind the scenes with things like the BBC News, where you see them, they've very often got a monitor slung underneath the camera and lens for various things. They can either use it for prompts or just to show the presenter what's going out. So that's what we use that for, and that's being fed also from that computer that we showed you a minute ago. That's computer number 3.
Yeah. Hang on, just zooming out.
Okay.
Okay.
So we want to now talk about the other. Well, just to rule it out, the computer on your left is doing the same job, isn't it?
Yeah, this computer here is basically the other one. This is, we're going to YouTube on this one, so we've got a YouTube window open and we've got OBS, and that's all that one is doing.
So again, that's just a streaming engine, basically, isn't it?
Yeah, we're not recording on that computer. That's a slightly older computer, so we do the recording on the slightly newer computer, which has got a faster chip in.
Yeah. And then the other computer that we use these 5 computers that we're talking about now in most productions is this one here. Tammy,
yeah,
do you want
this
to
one here.
We call this the Caption Mac.
It's called the Caption
It's
Mac.
our nickname for it.
Yeah,
really.
so any of the slides that you see on the screen, or any of the banners that I pop on. If I find the one with our name tag, you can see there's a green on there now, so we use chroma key. So if I now key that in with the mixer here, you'll see that our names are coming along.
We
the
forgot to
bottom.
mention that earlier, didn't we, chroma key? It's
We
another
did.
feature of this mixer switcher and many others as well. I'm sure a lot of you are familiar with it, but basically in digital or in everyday terms, it really, where it sees green, it takes that away from the picture. So that's why the caption that you can see on here now is on a green screen, and it cleanly puts it on top of it. Many, many years ago, in the earlier days of television, chroma key, where they'd use them for things like weather, was extremely difficult to do because they didn't have digital electronics to nicely separate video signals and produce nice clean cut images. But nowadays you can just do it in relatively low cost switches like this, so it's quite interesting and very useful tool, isn't it?
It is, yeah. So all of the slides and everything, we haven't used too many slides today. The agenda slide and things like that are all done on here, and then we can put them on the screen. We've got a few pictures in a moment which will come from this computer as well.
Yes, I mean, it is useful, and the biggest, the most complex production that we do now is for the Radio Society of Great Britain, and we do their AGM, and that's got something like 120, 130 slides, maybe a few more, because it's got things like the awards, and it's got various people coming in from all over the country, various directors of the RSGB and whatever, and it has to be quite carefully planned and scripted, with a very definite running order, because when you've got well over 12 people sometimes coming in, we've got to be organised, and so have they as well, to be able to come in at the right time. And for that you need lots of captions and graphics as well that the RSGB might want to show, financial graphics, that sort of thing. So it takes a long time. There's well over 100 slides that we use for that. Today we haven't got many, but maybe this is a good time, actually, Tammy, to show some of the pictures that you've got on there.
I've got one more computer.
Oh,
at the
sure,
moment.
yes, today.
So
yeah,
this is
the
our
next
normal
one.
setup that we've got here,
5
but we do actually have
computers,
one
yeah.
more computer here, which if I just go around slightly. So I've got another laptop here, and all that is doing basically, it's showing the countdown video timers. I use a separate Mac for that rather than having the Caption Mac do it, which in a normal program I would play any videos on the Caption Mac. But for when we do bigger productions, I like to have a separate input for that on the mixer. So it means I can, if I need to do anything on the Caption Mac in between times, it frees that up. And also that particular one has got a touch bar. And when you're playing videos, it's nice to know how long there is left on the video. Obviously the countdown timers count down themselves, but in a normal thing, you don't know how long a video is going to last. And the touch bar on the top of that tells you how much time is left. So we just have that as a separate input when we're doing something like this. So it enables us to mix and match a little bit more if we need to.
I did say we keep an eye on questions
Yeah,
and
we
comments
should
that come
go
in.
through some
I've
questions.
only got a couple, but one of them, Andrew's just given us a tip which we must look into. M1 DNS says, given your Mac based and like Zoom's second screen output, have a look at Zoom ISO. I think you'll find it useful. Yeah, we have a mixer which is ISO, which is a separate thing, which we might have time to talk about. But thank you, Andrew, for that tip. Yeah, we're going to take a note of that. And Tim MW0RUD, I think you've been a guest on this, guest presenter on this CAT in previous years. How do you get the video into the two streaming computers? That's actually fairly simple, Tim, to be honest, because you can regularly buy from places like Amazon even now HDMI splitters, so you can get the output from a mixer. This is actually, our mixer here has got quite a few outputs, but you can then take one HDMI output from something and split it into, say, 4, and that's what we do. So we take that one HDMI output, which is our master out, we feed it into one of the monitors here so that we can see the program out. Maybe my monitor in front of me as well, the little monitor under the camera. Plus we've got 2 separate feeds which take it into the 2 Macs that are doing the different streaming. Tammy.
And also what you should then say is that on some of the Macs, we have a video capture device, which actually
true, which was how we get it into it.
It's
yes,
how we get it into the Mac. We use just a little HDMI to USB video capture device.
I haven't got one separate to show you.
I don't know if
really.
I've got one on my shelf here.
It looks like a big USB dongle, a little bit like Martin said before, and it just looks like a dongle with HDMI in at one end and USB at the other. And we've tried fairly expensive things, and there's something just coming out soon which we've been trialling. But actually, in this case, some of the cheaper things that you see on eBay, don't worry too much about it. I'm sure that everybody can imagine it. But it's actually a fairly straightforward thing. You can literally buy them for £10 or £20 from Amazon, eBay, that sort of thing. But we found one that particularly works, so we bought several of them because it's absolutely critical for doing this. I think we've only had one fail in all the time.
Just touch some wood, please.
Touch wood, yes. Yeah.
There was one more question which we should address because it's still a question. Mike says, G0MJW, is that your club mast in the background? Looks amazing.
Oh, I didn't see that question.
It is. This was a mast that we had for a field day quite a few years ago in the backfield here. So it's a trailer.
It's not
a trailer
on our
tower,
house, is
isn't
it? Yeah, this is a trailer tower. We, for many years, Norfolk Amateur Radio Club, as many other clubs do, National Field Day. And for that, they put on quite a big station, actually in a field that we own just very near here. And we run a big event from here once a year called Radioactive and National Field Day weekend. And we happen to have these pictures. And so when we started doing this, remember, this was all unplanned, really. When we started off with just a piece of paper, blue tack to the wall. But when we realised we were going to do it for a little bit longer and that this lockdown thing was going to last some months and even years, then we decided to make some pull-up banners. So you're seeing behind the scenes now, but we've obviously got...
Yeah, we should actually just comment on why the BATC banner, why you can see a piece of wall above you. It's because, obviously, this shot of David is the main shot, and to get, obviously, the BATC logo in the corner and something that looks half sensible, we need to lower that banner. So this is really behind the scenes because nobody ever sees this. So there's a piece of wire and a new hook which basically attaches to the top of the banner, so it brings it down to the height that looks good on the close-up shot of David. And we also do that, a little secret for the Tonight at 8, the RSGB, because the Tonight at 8 logo is right at the top of the banner, and obviously that's not at the right height for the face, so we bring it down on something like that so it's in the right
Again,
place.
That was done in a rush. They never...
It was. If
we didn't...
If we'd have thought about it, we would. Our one that we have for the club, it says Norfolk Amateur Radio Club on it, and we actually did design it so it sits at the right height. So
on either camera, the name of the club name and everything does come in at the right place.
And the website sits in the right place, so it's just above your head when we're on a double shot. So,
we're revealing everything here.
We
aren't we?
are,
I feel like
we?
we're baring our souls, showing you what
Mike
it's like.
has asked another question about what is in front of me, Mike. We'll get to that in a little while because that's not something we normally have. So.
Yes, and by the way, Dave M5TXJ said, I hope this section will also be published to YouTube. Well, it's going there now. I can tell you, Dave, it's going there, uploading to the BATC's YouTube channel, and it will stay there. As far as I know, they're just going to leave it up here for the whole day. I know a friend of mine, a professional video editor, will be interested to watch. He mixes F1 and did Diana's funeral. Well, we've never done anything quite those heights, but I'm sure he'll be interested anyway to see what you can do as amateurs, really, because that's what we are. We just do this for several organisations. We never charge anything, and we're just pleased to do it. I'm also keen on trains. Can I mention trains? And there's an OO Live Steam Club, and I've helped them produce an AGM as well online the last few years. I mean, not many, let's be honest, and I don't want to be too dark here, but not much as good came from COVID for many, many people. But some of the things that it has done is enable people to get online more and be able to react. And so, although it's really nice that Norfolk Amateur Radio Club, like many other clubs, are back to meeting again in person, once we did get locked down, it gave our programme secretary the world of speakers to talk to, and so we've carried on with that now, and that's why we still do something online for Norfolk Amateur Radio Club, roughly on alternate Wednesdays, and we do a thing called NARC Live, and on that we have speakers from literally all around the world. Our speaker just a couple of days ago on Wednesday night is from Cyprus, talking to us about filters. So, you know, they really are, it does open the world up. And if you're keen on TV, as I have been, as I said, both in front and behind the camera, then it's been a nice time to get to know the sort of thing you can do. And there's some truly wonderful equipment that you can buy, as well as make as well. I'm guilty of not being able to make much stuff at the moment. But we are going to look at making a wireless tally system soon for our cameras. But anyway, mustn't get onto that too much now. We've got some slides to show you now, just to show you that when we do something bigger, and possibly one of the biggest things we do is the Radio Society of Great Britain's convention. We did this for 2 years online. together with CamHams, we produced 2 channels for them. Obviously, when COVID was here and everybody was locked down, and we did virtual ones. And then when the RSGB said, well, we'd like to get back to doing a real convention in person, but it would be nice to carry on a live stream for people who can't come to the convention because of where they are, or maybe their health, or maybe literally somewhere else in the world. So for we've just finished the 3rd one a couple of weeks ago at Milton Keynes, a big conference centre called Kent's Hill. You may have seen it. And this doesn't look too much really here, but there's quite a lot. This is the live stream studio that we built. It took most of a day to do it. We arrived about midday.
Yeah.
And we finished about 11 o'clock at night rigging this. And we're going to try and walk you around it now. This is where Noel came to see us one lunchtime and said, could you do something like this in your break? So this is why we're here, why we're doing this now. So let's have a look around anyway. We'll talk you through some of these pictures.
So this is the actual studio area. So to the left of the screen, you can see the 2 banners there. So that is where David sits for his head-on shots.
And that's really continuity in the old TV terms.
Yeah.
It's really, I'm just linking between lectures. You can see there's a light there. There are different cameras than we're using here. These are Blackmagic studio cameras. And again, if we have time, I've got one of them out of the box to be able to show you here if you're interested to see it. You can see a tally light on the top as well, which actually suggests that was live at the time and I'm not there, which is a bit worrying, isn't it?
I think I think this might have been after
it finished.
After it finished,
yeah.
yeah.
But anyway, you can see there I've also made a monitor bracket in the same as this. It's actually slightly bigger, and that sits under the camera on the left there. You can see a light. You can see a monitor so that I can see what's going out next to it. And then you can see, as Tammy says, we've got now, you can see there we've got a single chair and a sofa for interviews, which I conducted some of the interviews, and Steve Thomas and other people as well from the RSGB conducted some of them. And we set up this mini studio. There's 2 cameras there. So they're 4K Pro Blackmagic cameras, studio cameras. And we'll try and show you one at the end as well if we've got time. So this is from the other point. This is Tammy's point of view. So talk us through this, Tammy.
Yeah, so this is sort of where I sit. So to the left monitor there, that is our streamer. We only stream to YouTube on the convention. So that monitor and Mac on the windowsill there is the streamer. The sound mixer next to it, we actually don't use an audio mixer at the convention. Because we use a bigger mixer, which is half in that screen. I'll show you that in a moment.
Which is video and audio, isn't it?
It's video and audio. So the audio mixer you can see on the left there is actually a Talkback system. So that goes into some packs that David and Kevin and Heather, who are with us, they all have one of these. So they can all hear what's going out on the stream at any one time. And there's also a microphone there, just right next to the mixer. You can see the blue thing in the middle there. So I can turn the audio mixer up and I can actually talk to them. So when David is live, I can talk in his ear when he's doing an interview and say, 30 seconds, 20 seconds, 1 minute warning. Or if they've got a website they want to show on the screen, then I can say website, and he'll know that the website has been put up at that time. So
and they're wireless, aren't they? I don't know if you mentioned
they're
that.
wireless, those packs.
They're called in-ear monitors if you're interested. Excuse me. Often used by bands and people like that on stage and things to get feedback or foldback into their ears so they can hear what they're sounding like and block out a lot of the other sort of sounds. But we're using it, using it really for this. And it means that other studios at the Kent's Hill as well, other rooms, lecture rooms, the range was such where they could have one of these in-ear monitors as well.
Yeah, so they know what's going on.
And again, not really
stream.
expensive, not as they go. I mean, I'd be lovely to have had time to make them, but we've got a pack of 6 of these receivers, which several of us walk around. The producer of the convention, the live stream as well, Heather Parsons, she has one in her ear, so she can hear what's going out at all times. So it's quite a good way for Tammy to be able to communicate. Talkback, actually, that's what that is.
Yeah.
It's Talkback.
Yeah, Talkback, yeah. So the next Mac with the green on the screen there, that is our media Mac. So that basically plays out all the videos that we use during the convention. I'm actually going to go to the next slide because you can see what's better there. So the screen on the top left there is program out, so that is obviously what's going out all the time. The Mac below it is the caption Mac, again like the caption Mac that we use in the studio here, it's the same Mac, and that has all the slides and everything on and all the captions. The monitor straight in the middle is the feed that's coming out of the mixer, so it's all the channels that you can see.
This is the main
there.
mixer,
This
isn't
is
it,
the
in
main
front of
mixer,
us,
the main mixer in front of us
Just
here.
for people just who are interested, this is called a Blackmagic
HD8.
HD8 television studio ISO, and the ISO means basically that inside it has got some 2 terabytes of storage, and it can also store all of the video inputs as well as the output, and that can be useful if you're doing, say, a live event. But let's say Tammy accidentally cuts to a wrong camera, or a cameraman moves just as she's cutting to it, so that the live feed, obviously there's nothing you can do about that because it's gone out. But later in post-production, you can take those files of all of the cameras. They've all got a time code, which basically means they're all locked together. They all have the same synchronization code, basically. You can put that into a computing editor, and then you can re-edit it to take out the shot that she used and maybe use a wide shot or something that was there as well.
Yeah.
That's just to explain what ISO means on a video mixer.
So we said that this is a video and audio. I don't know if you can see it very well, but on the I'm afraid I can't use my mouse to show you. I thought I could on here. But there's 10 knobs on the top left of the mixer,
the big mixer,
on the flat piece. That is actually the audio that comes in, because we find that it would be too complex to have an audio mixer as well as a video mixer, which would also mean more cables. And obviously, I've got enough to do, press some buttons and things, and doing everything.
Can I just say at this point, Tammy, just to set the scene a bit better for people, if you've never been to the RSGB convention, there are 4 lecture theatres, all with different things going on. We have got all 4 video feeds, actually, haven't we, coming into
we do,
here?
Yeah.
We could bore you crazy with how it's done. It's actually done over their intranet system of the place, but basically we end up with 4 video sources. Tammy's got all of that. The audio from those different lectures is all embedded in with the video, actually. And that's why it makes sense to just use the mixer to handle this audio, because Tammy's just doing all of this on her own from all of these different sources, plus live interviews potentially from the little studio behind. And if to have a separate audio mixer, which would be the ideal way, don't get us wrong, would just be really too much for one operator to do.
Yeah, so I can turn the audio up and down on those dials. I can preset that because I can see what the levels are like before I actually switch the audio on. And on quite a few of those feeds, we have something which is called AFV, which is audio follow video. So when you go to the HDMI source on the mixer, it actually takes the audio and it'll switch it on while you're looking at that source. And then when you come off it, it'll switch it off. That's a little bit different for some of the microphones because we split some microphones, which I'll tell you about in a minute. But for the things like the videos and the feeds from the lecture rooms, and we also take a feed from a radio van outside, for all those we do put audio follow video, so the audio is just always there when we cut to that. With the studio that we've got there with the seats, we did have a point where there's 4 people talking. There's 1 interviewer and 3 people being interviewed. And with the Blackmagic cameras, you can put 2 mics into each camera. So what we do with that is we put those 4 mics into the 2 studio cameras, and we can then split the audio. You can have it. So
that, can I just explain to you?
Yeah,
sorry, one little bit
please
you
do.
mentioned is that the output in the terms of workflow, which basically the cabling system we use from those professional cameras is SDI. SDI is a little bit like HDMI, except it's a professional standard where you can in particular have much longer cable runs. But just like HDMI as well, within that SDI channel, you can embed the audio. And as Tammy said, to reduce the number of cables, and believe me, there are a heck of a lot of cables. As I said, this takes us a day to rig. This does reduce the cabling because we only have 1 cable coming out of that camera from SDI, and that includes these 2 separate microphones which have been plugged into the XLRs at the top.
Yeah, So we split those. So we basically have 4 microphones coming out of 2 cameras. And with those, because we split the audio channels, I can't use the audio full of video. So I have to, any of the microphones that are in the studio that I have to switch on manually. So I've got to think about what I'm doing at the time. Anyway, we've gone off track on the picture now. So next on the picture, so the monitor on the top right, that is actually linked to another mixer, which you can see just below it. Which
That's
is
called a Blackmagic ATEM Extreme.
Mini Extreme.
Mini Extreme.
Because there's only 8 channels on the main audio, on the main mixer, we actually need more than that because we're greedy. And we've got other cameras that we want to use. So we have to have 2 mixers. So one of the channels on the main mixer is actually going to the sub mixer, so to speak. And then we've got another 3 channels on that. So effectively, we're actually using 10 channels for the convention rather than the 8 that we have. And that's just so we've got a couple of extra, like this year we had a PTZ camera, which was an overview of our studio, which we don't use that shot very often, but we call them safety shots, because if anything did go wrong, we could just go to one of those just for a few minutes and it wouldn't look, you know, you don't want to blank the screen or something. So we call those the safety shots.
And we also, in the room below where we were here, which is called the Special Interest Group Room, we have a mobile camera that we've built, which is basically one of these studio cameras, the Blackmagic studio cameras, on a tripod, which is mounted on a dolly, and we've put some wireless links on that so that it's completely free of wires, so that we can walk about with that in the room downstairs. Now, when Kevin, our cameraman, is walking about with it, and I'm presenting, and we need to get to, say, talk to another special interest group from one to another, that's when Tammy can use this wide shot that's coming in from a PTZ camera that we've mounted downstairs. Each year, I think it's fair to say, Tammy, because we mustn't, you know, we must share, as I said, we are amateurs at this. This is just our passion, our enthusiasm, and we try and make it a little bit better every year, and we try and do something different. And we've used the PTZs to more effect this year.
We have, yeah. Right, let me move on to the next picture, which is a little bit further around the desk. So the Mac on the bottom left there is, what is that? Just trying to think.
I don't know. I don't see that side of it.
That's all right. Couldn't think what it was. So that Mac on the bottom left, no, that is actually, with the ATEM, there's some good software. Which you can do things with. You can split audio channels. There's just anything that you can do on the mixer, you can do in the software plus more. So that is all that one's doing.
It can be a bit easier and quicker to do it.
It can sometimes, and if you have a problem or anything, and also you can preset. So if you switch it off at night and then you switch it back on in the morning, you can then load your settings, and it will put them exactly the same. It will change the colours on the camera and everything that you've preset the day before. The Mac on the top there with the green mouse on the top, that is one of the computers we use to take the RTMP feed, which is the feed that's come from the lecture rooms. The Mac next to it was also the same. So we have a constant feed from the GB3HQ, which is the outside broadcast fan. Or not outside broadcast, is it? It's
it's a special event station.
Yeah. So we constantly have that feed there because we can always go to that. That is another safety shot that we have. And then one of the computers is on the lecture room of the lecture that we were doing at the time.
Yeah, I mean, I said I wasn't going to go into the detail of it because I'm amazed how much time has already gone. But basically, you've got the massive convention centre. If you've never been there, it's called Kent's Hill. It has a hotel and everything all built into it. And these lecture rooms are very, very well spread out. And because we don't run cables, expensive cables that could get damaged and get in people's way as well, and people trip over everywhere. Our friends at CamHams cleverly wrote some software a few years ago which basically turns each of those lecture rooms into a mini RTMP streamer, which basically converts the video and audio signal from them, puts it into the network in the conference centre that's already there. The structure of cables, you know, that's there, like structured cabling, if you know what that means. In modern businesses and buildings, you have Cat5 and Cat6 Ethernet cables going everywhere. And basically it sends those signals down there, and we pull them out at this end using a high-speed switch and break it out into all those different Macs, because we have got, 4 different lecture rooms to take feeds from, plus the special event station outside, plus all the cameras and things that you see in the studio. So that's what it's all about.
Yep. Next Mac at the bottom there is that is David's auto cue Mac. So
you can send messages and
so yeah,
prompts
we
and
can
stuff,
change
yeah.
his auto cue, or he can do it himself. But so he's got a keyboard and a mouse on his desk. And
well, it's really important that people can talk to me, because if I'm doing the continuity between it, you can imagine we've got lectures going around all over the place, starting at different times. I need to know if someone's running late, and I need to fill or whatever. So that's their way of communicating with me to the monitor that's just under the camera.
The Mac, actually, it's not a Mac. The PC.
That's another one we borrowed.
We borrowed that.
We ran out of computers.
We don't have any PCs, so that basically has all the 4 RTMP streams. So if we had a problem with one of the lecture rooms that we were going to take, we could then hop onto a different one to see what they're doing in there. So it just monitors them. The next screen that says PTZ Optics on, that's switched off there. Obviously, that shows the PTZ camera and the controller next to it, which is actually what I've got on the desk here. We'll show you.
We might have time to quickly show you
in a moment.
Yeah.
That is actually so we can see where we're moving the joystick, so see where we're moving the camera. So, and then this picture here is just that's
just the wide lot. So it's quite a lot. And if you imagine each one of those things has got multiple cameras and cables and everything, it has to be connected up and tested. That's why it takes such a long time. And this is what we call a hobby. But anyway, I hope that's given you some insight into doing quite a large outside broadcast with many different feeds and sources. It takes a lot of preparation, both on the technical front from us. You know, we have to set this all up here, make sure we're going to take every single cable and plug and tool that we need when we're going as far as Milton Keynes from here in Norfolk. And also, of course, lots of planning for the whole event from the RSGB and timing and everything. And it's fair to say these in-ear earpieces have really helped, haven't they? Because each of the lecture rooms can hear where we are and when we introduce a talk. Because, of course, we're only there really to stream for the benefit of people watching at home. The most important thing is actually what's going on there at the conference. It's there for the delegates that are there. But it's still nice to be professional on time for everybody at home. So that's been a really useful thing to do. And for us to learn, really. We may just have time now if it's of interest to you. We haven't got any other questions, I think, come in. If you have got any, you're welcome to ask them, because we're going to keep to time, just like we have for everybody else today. But we'd like to show you a couple of toys, really. What should we show first? We've got a couple of things we thought if we had time, we'd be interested to see.
Let's do, because I've actually zoomed in on it now. So right. the PTZ controller, we'll show PTZ in a minute, but this is the controller.
So firstly, let's go to basics, in case someone watching and think, what's a PTZ? They keep talking about this.
Right, well, let me get PTZ.
That stands for pan, tilt and zoom. And there are many cameras often used in security, but even more often now used in television, because they're remotely controlled. Just for those of you who don't know, pan is left and right. So that's a camera here mounted on that. Tilt is that. And then zoom is obviously the zoom lens that's built inside that allows you to go close up. These have been very expensive for many years, but we found this particular brand has been really good. It's got both HDMI and SDI output.
Hold it up to that
camera? I can hold it up to the close up there so you can see the output controls there. So this has got quite a few outputs on there. The reason for SDI, I think I did mention it earlier, is that you can send signals for so much further. You can go up to 100 meters away, whereas HDMI, I think the technical limit maximum is 7.6 meters. In practice, you can go to about 10. But anyway, this is a really good quality camera. These have got 30 times zoom lens built in. And we've got 2 in this room at the moment. The one behind is giving you the wide shots, which Tammy can show you now, a wide shot.
Well, it's not a wide shot anymore.
Okay, you've got it on your controller. So these are, you can either control them with a remote control that you get with them, or even better, as we've just upgraded to, you can buy a dedicated PTZ controller. Now you can buy these relatively cheaply, particularly for security applications, where you've got PTZ cameras that are on houses and buildings and things. But this one is designed more for broadcasters, and Tammy's going to show it to you now. It's really nicely made. For those of you who like good engineering, this is all metal, this case and everything. And you can control directly with this up to, I think, 9 different cameras, or 6 with with presets there. It's not time to go into all the details of this, but Tammy can basically control the camera that's looking at this now with this.
So if I twist this way, obviously we've got zoom out, and then we've got move around. This is, to be fair, this is not my department. This is the first time I've used this today.
Yeah, Kevin is cameraman.
It's normally someone else who does this. So yeah, that's what I've got on the desk here that I've been controlling that camera with today. But
you can change, for those of you interested, you could change things like colour balance and all sorts of internal functions if your cameras are compatible. There's various standards you might be aware called VISCA and other ones as well. And if it follows one of those standards, you can just see up there the control saying white balance. And what else have we got up there? One push trigger, backlight, exposure cycle. And you can control each one of the cameras for this. And you can even control the speed. And if I've got zoom here, so I can do it really quite slowly and quite gradually if you don't want to use the joystick. So this is a nice box, quite a lot of money, about £800 I think this cost. So it's not cheap, but then nothing in our hobby seems to be. One thing we've discovered this year, just to share with you something, is that I'm a hardware man at heart, and I like to see electronic wires and things that I know and can control. I'm not particularly software based either, but we've trusted Power over Ethernet this year, and this whole box and the camera that you're watching is all controlled and connected by Power over Ethernet. Yeah, we've got and which means it's just one wire. Just one wire going in this. And now, if we're a little bit more ambitious next year at the convention, we can control multiple cameras like this and just basically have its own Ethernet network, both for the control and power, and also the pictures we're experimenting with. You can get quite good video streams from them. There's a little bit of latency, which means delay, but it's not bad. Now, I see time is rushing on really. We'd like to show you a couple of things specifically. So we've shown you that. Hopefully, Mike, that answered your question what this box was in front. It's PTZ Optics this is made by the way. But let's say there are ones you can get for about £150, £200 to control cameras. This is a bit more, but it does a lot more as well. And it has got an HDMI output, which means you can take a direct video feed if your camera supports it. Now we're going to show you another version of these PTZ cameras up here. And this is something we're experimenting with. So Tammy, can we have a look at that camera from the outside first? Okay. Right, so this is it. You could just see it's at the back end of our little studio here. It looks the same as the camera that you just had in your hand. But this one has got the magic thing that Dave mentioned earlier on in his talk, AI. And I thought it would be worth trying one. It will automatically follow. It will find a presenter and follow it. Now, what we're going to, I don't know if I'm putting you on the spot now, Tammy. Is it possible to take the feed from that and put it as a picture-in-picture so that people can see what the camera does? Yep. I know that's very much putting you on the spot. I think I can if I just move that to one side. So now this camera, though you can't probably picture this, is actually looking at me at the moment. It has been for the last, three-quarters of an hour. And it's semi-intelligent. It identifies somebody, maybe because I've got a blue shirt on, and it should follow me and track me. Okay, hang on. Right, here we go. And so there we are. That's the picture coming from it. Now, if I stand up, just watch my I've got to watch my mic because I'm wired up here. So I'm going to stand up. You'll see that it actually moves to adapt quite smoothly and slowly. We're not touching our controller or anything like that. And given the limits of my wire, if I move to the right now, it should follow you quite gently, and to the left. Now that's pretty good, I think you'll agree. So if you have a club or an organisation that does a lot of presentations and you want a camera that's focused maybe on the presenter, I think this is doing a really good job. I'll tell you in a minute about the cost as well. It's not anything like as expensive as you imagine. And importantly, if you're doing this with just 2 or 3 people, it does allow you or the director like Tammy or Kevin, who normally operates our cameras, he can then manually operate other cameras, for example, for questions from an audience. So we're going to build up a set of 3 or 4 of these for club talks so that we can record them. And we'll probably use an AI camera, which we've used for one talk so far as an experiment, for the presenter, like this, where we don't have to have any cameraman looking at it. And then camera operators can be manually controlling who is going to ask a question in the audience, that sort of thing, which an AI camera won't be able to do, at least yet. There's nothing more to show you really from that, except to say that remarkably, even since I bought it, how much did I tell you I paid for it? It was about £600 when I bought it, but I see that the price is now down to about £400 for this camera. and it is very good. If you're interested in it specifically, I don't particularly want to advertise it as such here, but just drop me an email or talk through the club, and I'll be happy to link you to where I got it from, because they're not all going to be as good as this, I think, but we found this manufacturer, which you can see on the front actually, SMTAV, are particularly good, and there's not much of a surcharge for this AI function, which by the way you can switch on and off, so you can manually control this. I can't really show you anymore. If I sit down again though, you'll notice it just gently follows me, and there's nobody over there.
Yeah.
Pretty good, isn't it?
And it doesn't, if I'm moving, it doesn't want to know me or anything.
It's just me. So if I do move over here, it will move to follow.
Yeah.
I'm noticing our time, and we mustn't be late
No, we
for other
mustn't.
guests. So we've got quick time to quickly show you something,
Yeah.
which is one of these PTZ.
Hang on.
If you could put us on a camera, Tammy.
Yeah.
Thank you. This is asking you to do a lot. So I just thought you'd be interested to see this. This is a bit of a beast. This is called the Blackmagic 4K Studio Pro camera. It's got a nice monitor in the back, which opens out as a viewfinder, a touch screen, and you've got various options on here. We've got a lens that we've fixed on the front. Obviously, you can change that lens, and all of this can be remotely controlled, by the way, as well, from a Blackmagic switcher. So we've found it really very useful. If you're working in television and there's multiple cameras, it's not been too bad for me today because there's only two that we've generally used, but then this is called a tally light, and that comes on to tell the presenter when their camera is live, and that can be really useful. It actually goes red or green to say it's the next camera on, and I can't really do it justice in the few minutes that we've got here, but there's those inputs that Tammy talked about. There's those XLR inputs, and the great thing is if you plug external mics into those, it will embed all of this into the SDI feed to the mixer, or HDMI. This has got, I think, both. Yes, it's got both, but SDI for long distance, and it's amazing what you can do with it. This is an expensive hobby, as I said, but then lots of us have expensive hobbies, I guess. I hope that's given you an insight into what we do here. I hope you've enjoyed this. If not, I hope you've had a nice lunch, and we look forward to joining you very soon for the final talk of the CAT24. Thanks very much for bearing with us, and we'll see you again very soon.
sure it'll be fine.
Welcome back to the final session of CAT24. Now, Noel G8GTZ is another person who has been involved in the running of BATC for a long time, and he's currently our secretary. Well, today Noel is here to bring us the latest on HAMTV and how to receive ATV pictures from the International Space Station once transmissions start. And if you've got any questions or comments for Noel, just pop them into the BATC or YouTube chat, and I'll read as many as I can to him after the presentation. So welcome to you to CAT24, Noel.
Yes, good afternoon, David, and good afternoon, everybody else, and Tammy. I thought that was an excellent lunchtime break. That was really, really interesting to hear all about that, and I can see one or two people thinking about that, those pan and tilt cameras, and we're looking at reviewing the BATC streaming kit. So we may well take a look at those cameras ourselves. So no, very, very interesting. Thank you very much, David. Right, so this afternoon, I thought we'd kick off by looking at HAMTV from the ISS. And of course, the big question that everybody's asking is, when is it going to appear? And I'll be covering that in the presentation. The version of this presentation that I'm using is actually a bit more of a wider one than I normally do, in that I thought it'd be useful to look at the background of the ISS and some of the other signals that come from it before we zoom in on HAMTV. So a couple of slides on the ISS, background to ARIS, look at some of the other signals that come from there, and then focus in on HAMTV. The ISS is give it its correct title, is a habitable artificial satellite in low Earth orbit. It's built and maintained by the 5 major space agencies, and it was built in modules, built by parts, the first of which was launched into orbit in 1998, and now it's complete. It is actually the largest artificial object or artificial body in orbit. And it consists of a number of pressurized modules, which are the living compartments, and then solar arrays and other components. And it maintains an orbit of between 330 and 435 kilometers, about 220 miles. And it maintains that, or that orbit is maintained by reboosts, maneuvers from using engines either from visiting spacecraft or the Xena module. And these reboosts will take it, because it will naturally decline and come in towards the Earth. These reboosts take it back up again, and they do actually play quite an important part in tracking the ISS, because obviously as the orbit goes further up away from the Earth, the orbital time changes, and that affects the actual orbits. And if you watch the ARIS contact a couple of weeks ago, that was affected by a reboost which had happened overnight, and so some of the orbital data that was they had was out because of the reboot. Amateur radio on the ISS was first used on the Space Shuttle in 1983, and ARIS is actually a program of volunteers, and their goal is to give students the taste of the excitement of amateur radio, and in particular by talking directly with crew members on the ISS. And the idea is to inspire people to have interesting careers in STEM. And most of the radio contacts on the ISS are coordinated by ARIS. We'll come on to the ones that aren't actually coordinated by ARIS, but most of the contacts are coordinated by ARIS. ARIS is a formal organization. As I say, it is staffed with volunteers, and it partners with the national space agencies from Japan, European Space Agency, Canada, NASA, and the Russian Space Agency. And they're the 5 agencies that run the ISS. And the UK Space Agency is part of ESA, and they sponsor a lot of the ARIS contacts we do in the UK to cover our costs. All of these projects are coordinated by a local team and by an international team, and all of the contacts are allocated by the space agencies months ahead before the actual event. And the reason for this is that a typical cruise schedule on the ISS is pretty tight. They don't have that much free time. So any activities that happen on board the ISS need to be coordinated into this cruise schedule. And it's done on a week-by-week basis. And 20 minutes is allowed for a voice call, or 40 minutes is allowed for a HAMTV call. But an astronaut's time is pretty much tied down throughout the day. They obviously have rest time in the evenings, but during the day, their time is pretty much taken care of. So, what signals come from the ISS? Well, there are 4 or 5 types. There's the packet radio repeater, there's SSTV images, there's occasional voice contacts, which are very distinct from the ARIS schools contacts, and then there's HAMTV, which gives us live pictures. And that picture there is one that was taken in 2016 during Tim's contact. And there he is. And in those days, we were using an Ericsson handheld on board the ISS. And that handheld there is exactly what he used on 2 meters to make all of the school's contacts. As we'll see in a moment, that has now been upgraded and has been replaced by some proper Kenwood equipment. But it's incredible to think for about 20 years that all of the ARIS ISS contacts were done using that Ericsson handheld. So on board the ISS today, there is a couple of Kenwood D710s, which have been modified and use an AMSAT developed multi-voltage power supply, because there isn't much 12 volts around in the ISS. And there's one of those installed in the Columbus module in 2020, and that's used for the student contacts, but is also used for the crossband voice repeater. And the second unit was installed in later 2020, and is in the Russian service module. And that's the one that's used for packet radio applications and also for the slow scan TV events. And then, of course, there is the HAMTV transmitter, which is the thing that we're all interested in. So outside the ISS, well, first thing to say, it's not a great place to mount your antennas. There's a lot of clutter up there. Solar panels, thermal radiating panels, and of course the visiting spacecraft get attached underneath, and then there's robotic arms. And to add to the complexity, the ISS flies, I use that term loosely, flies slightly nose down to protect the cupola windows. So the windows on the viewing platform are protected from space debris by flying slightly nose down. But of course, this affects radio performance as it rises up from the west. If you think about it, as it's coming towards us, if it's flying slightly nose down, it can be a little bit difficult. The pictures there show, the first picture shows the HAMTV patch antenna. So it's a 2.3 gig patch antenna, which is bolted to the outside. And the other picture shows the astronaut installing the VHF antenna on the outside of Columbus. So the ARIS schools contacts are, as I said, pre-planned, with 20 minutes allocated for a voice call and 40 for a video call. And the 5 space agency regions are allocated an equal number of contacts throughout each year. And so ESA gets a number of contacts which are then distributed between all the countries in ESA. And we generally end up with 1, maybe 2 in the UK a year. And when Tim Peake was up there, was a bit of an exception. And ARIS UK managed to fully Arish Europe into allowing us 10 contacts, which was incredible. So the contacts are planned anything up to 12 months ahead. And then a school who has applied for a contact is notified anything up to 6 months ahead of the when the best week will be. But the actual date and time is only confirmed 10 days ahead. And that, happens only once everybody has agreed that. And last minute changes can happen. As I say, that's exactly what happened 3 weeks ago when they did the contact from Brookwood with the Girl Guides. There was some changes in the ISS scheduling, and so it actually happened on an orbit before the planned orbit. So it was very unusual, in so much as Sophie, the Princess of Edinburgh, or Duchess of Edinburgh, was attending the event, and there's very little changes of royal household plan. But actually, the ISS did change the household plan, and that contact happened 96 minutes before it should have done. Not only that, but as I say, the orbital data was incorrect because there'd been a reboost overnight. But all in all, it was done, and there was some last-minute panics with the team, but it was a good contact, and it happened well. Right, so there are non-planned voice contacts on 144-800. You hear people occasionally work an astronaut, and that's done during their free time. There are occasionally on board astronauts who have an interest in amateur radio, and they can pop into the shack and make contacts, but they're purely done on an ad hoc basis in the astronaut's free time. So, getting round to the meat of the conversation, HAMTV. HAMTV enables live video to be transmitted by astronauts from the ISS using the 13-centimeter band. The original HAMTV unit was installed in 2013 and commissioned in 2014. And actually, Colin G4KLB was one of the very few people to actually catch the commissioning tests in 2014. And there's an excellent video by Colin of those commissioning tests on YouTube. And of course, the reason why we all remember it is it was used on the Tim Peake Aris contacts in 2016. And there you can see it, the blue box in the Columbus module. Unfortunately, after we used it for Tim Peake, a couple of years later, it actually failed. And eventually it was shipped back to Kaiser Italia, who were the original systems integrator in Italy. It was shipped back for repair in 2019. So the specifications, 2395 megahertz. Transmit power is 10 watts. The cable and filter, we believe, gives us at least a good 6 dB loss, and I'll talk more about that shortly, which means there's only a couple of watts available at the antenna. It is because of the age of the equipment and the generation it is DVB-S, not DVB-S2. And it's 2 megasymbols, MPEG-2 video. So unfortunately, both the RF performance and the video quality is not state-of-the-art. And coupled to the fact when it was originally up there, it was used with NTSC cameras. And this time round, it will be NTSC, it will be HDMI cameras converted down to NTSC. So the video quality isn't going to be much better. We know we could do better than this, but given the hassle to type approve and get authorization to use different equipment, it really is not something that's going to happen in the short term. But I will talk about what the plans are for the future at the end of this. So its current status, which is of course the thing that we all want to know about, is, as I said, the unit was repaired in Italy and it was sent back to Aris USA in 2023. However, unfortunately, there was some testing done, RF testing done, which showed that we need the need for some more TX filtering, possibly because it wasn't thoroughly tested before it went up last time, and possibly because NASA specifications have changed. But anyway, it needed an external bandpass filter. BATC was heavily involved in this. Dave and Phil and I and Graham had several calls with Aris US and offered advice on getting a suitable filter to be put up on the unit. Eventually, they found one and it was tested, and it eventually went back to the ISS in March this year. However, the bad news is that the external bandpass filter that we fitted along with the accompanying fly leads and adapters means it's probably going to be 3 dB lower than it was when it was in orbit last time round. Now, we don't believe that's going to make too much difference. Possibly at the margins it may. So if you're trying to catch a low orbit, it may, but certainly overhead you will not notice the difference by 3 dB. Right, so it is on the space. It is on the space station. It was taken, as I say, in March on a SpaceX flight, but it needs to be installed and commissioned by trained astronauts. Now, that was going to happen, but the plan kind of got delayed a bit, and the latest is that unfortunately something got installed in the hole that the HAMTV was whilst it was away. In the 5 years that it was away, something else got put in its place, and so they're doing a topographical reassessment, I think is the word that it was used. So there's a topographical reassessment going on. Basically, they're trying to decide what boxes they would have to move to reinstall it, or if they can reinstall it somewhere else. This is ongoing. The latest is that work is almost complete. But then it does need to be installed, and it needs to be commissioned by an astronaut who's been trained on it. So hopefully, we're hoping that will be complete by the end of 2024. So we might get some fun this winter. But as Graham G3VZV always says, is space schedules only ever move to the right. Things never happen sooner than you plan them to happen. So it's kind of watch this space, but it is definitely going to happen. And it's worthwhile thinking about how perhaps next spring you can receive pictures from the ISS. Once it's back up and commissioned, the big question everybody will ask, of course, is when will it be turned on? Truth of the matter is we don't know. In 2016, it was mainly used for Aris schools contacts, but the transmitter was on at other times, but with no video. The best thing to do is once it is commissioned, it will be tested before the contacts. And the best thing to do really is to have a look at this Aris page, which is amsat.org/status. And that page will give you when it is destined to be turned on. But we're a bit of a way before you need to know about that. Because what you really need to know about right now is receiving HAMTV. And there's kind of two solutions, all of which end up in the same place. The common bits really are you need an antenna, probably a dish, and certainly with a trackable XY rotator. You then need a piece of feeder, which is higher quality as possible and even shorter than that. So as high quality and as short as possible. And then after that, the choice is kind of yours, but we would recommend the the blue lines, the blue block diagram, and that's where you don't down convert to an IF frequency at the masthead. You stay at 2.4 gigahertz. And so you need a 2.4 gigahertz low noise amplifier. I'll talk about these blocks a little bit more. You then need a satellite line amplifier into a bandpass filter, probably with another satellite line amplifier, and then feed that into the Mini Tuner V2 or Pico Tuner card. That card can then be run into Open Tuner, Mini Tuner, or the Ride set-top box. The only reason to go the other way is if you're running something like a Mini Tuner Mark 1 or a consumer set-top box. And the reason for doing that is they don't natively cover 2.4 to 2395 megahertz. And so you need to do a down conversion. And if you're going to do a down conversion, you might as well do that at the masthead. And so you can use less quality coax and possibly less gain in your down leads. You will still need a bandpass filter, and you will then have to run either Mini Tuner or a consumer set-top box, because that's the way it will work. So we're going to talk through some of the elements now of the receiving solution. So how to receive it, antennas. It is possible to receive HAMTV on a simple antenna when the ISS is overhead. And what the first picture shows is Graham, G3VZV, sitting at Goon Hilly with a G3RUH patch antenna on a dish, a 60 centimeter dish. And he received pictures from the ISS. This was taken in 2015, in the early days when we were doing commissioning tests down at Goon Hilly. There was no formal transmissions, and he received pictures on that dish on his lap. But if you want to receive more than 5 minutes, you will need higher gain antennas and the ability to track it accurately. And we think that the 1.2 meter dish, that size, is optimum. Smaller dishes are easier to track, but obviously don't have so much gain. And here's a thought for all of you on Oscar 100. The transmissions are right-hand circular. So in theory, the potty patch antenna may be able to receive the ISS. And here's even more of a random thought. Once it gets commissioned, occasionally the ISS will fly in front of Oscar 100. So you should, in theory, for about 16 seconds, possibly be able to receive the ISS on your 2.3 gig transmit antenna using your dish lined on QO100. Wouldn't recommend it as a permanent solution, though, but I'm sure somebody will try it. So what comes after the dish? Well, you need an LNA, low noise amplifier, with a bandpass filter at masthead. The LNA, the noise figure needs to be good. It needs to be around about 1 dB, and it needs at least 15 dB of gain. And now you need a filter. Now, I know amateurs tend to regard filters as optional extras or luxuries. It's not in this case. If you have a look at the picture on the right-hand side, you can see Wi-Fi channel 1, and you can see HAMTV. There is no way that a wideband satellite tuner, which is what we're using, no matter which solution you use, will be able to lock to HAMTV without some form of filtering, because it's getting on for 20 dB louder. That picture was actually taken by Phil, M0DNY, during the original HAMTV sessions. So a good filter to notch out Wi-Fi, professional satellite coax, line amplifier in the shack, because you need to have a noise floor which is at least -70 into your receiver. Don't forget that these satellite tuners we use were designed to be used with a broadcast LNB, the electronics on the back end of your dish. And those LNBs have typically got 55 dB of gain. And so we do need to have lots of gain in front of the tuner. And it's the same if you're doing terrestrial television, you know that. If you're doing terrestrial amateur television is what I mean. And a point to note again is that standard satellite receivers only cover up to 2150. So you will be needing to use a down converter if you're not using the Serret 4334 tuner. So any DVB-S receiver may work. If you remember last time around, there was an issue that they wouldn't. We all had to run mini tuner because of that, because there was an error in the DVB service information. That is now corrected. However, with a standard domestic DVB-S receiver, you need to scan for signals. And to try and do that during the ISS pass is going to be hard. But the major factor is that you can't cover 2395 natively, so you do have to down convert. The Serret base receivers will tune to 2395 and don't need the down converter. So either the mini tuner or the Pico tuner, and the Mark 1 mini tuner does not use 4334 NIM, so therefore will not tune to 2395 natively. So unless you're going to build a down converter, you can't use the Mark 1 mini tuner. So you've got your mini tuner. You need a receiver. Well, the BATC Ride, Portsdown, and Longmins have all been tested and will receive HAMTV. How do we know that? Because we did some I&Q recordings when it was last up on the ISS. We recorded the I&Q data of it, and we played that back through SDRs, and we have checked that Portsdown Ride and Longmin will receive HAMTV. And the top picture there of Tim shows him with a Portsdown overlay, which you would not have had a while ago. You could not have got that when it was originally up. Mini tuner and open tuner will also receive it. Tom has done some work on open tuner, and we know mini tuner works. We haven't tested any of the software only solutions, but we would be interested to know what other people have done. The two candidates I know about are SDR Angel and Sat Dump. And we'd be more than willing to publish an article in CQTV on any tests that people have done with either of those two programs. So mini tuner, preferably Mark II, into a Ride, a Portsdown mini tuner, or open tuner. So that's the receive system you need. But that's not quite all of it, because actually we've all got a bit lazy in the last 5 years. This is not like QO100. It moves at 27,300 kilometers per hour. And so a pass only lasts for 11 minutes. So the maximum view you've got of it is going to be 11 minutes. And from that, in that time, it will have tracked from horizon to horizon. And the 1.2 meter dish has got a beam width of about 6 degrees. So your dish needs to track it fairly accurately in all planes. And so you will need an XY rotator. The most common one is the Yaesu GR5600, which is in the picture there with a RF hams dish. That will track it accurately enough. That will track it accurately enough. I know people are looking at doing their own thing. That's fine. But then you need computer control tracking. You need something like PS2 rotator, which is the one of choice that I use, or SAT32, to control the controller rotator. So you've got all of this assembled. You've got your dish in the air. You've got your receiver working, but the ISS isn't on. So what do? Well, first of all, you can't wait until the ISS gets on, because that will be too late. You need to have tested your system before it becomes available. And the first thing to do is you can use the sun to test your dish system. So on those rotator control programs, you can set them to track the sun. And the bottom line is your dish should follow it all day. Now, if you've got a prime focus dish, you're really laughing, because actually on a prime focus dish, you can mechanically adjust the dish to have the shadow of the feed at the center hit the boss at the back of the dish. So it should, the LMB or the dish feed shadow should be dead centered on the back of the center of the dish. With an offset dish, unfortunately, it's slightly harder. You can't do that. And so the way to do it is something Dave talked about earlier on, which is the noise power meter. So you take your Portsdown and run the noise power application and track the dish. And you saw the results from Gareth's dish being tracked. And you've got all of the tools there in Portsdown to do it, so it really shouldn't challenge you too much, and you will be able to receive sun noise. And what you need to do is test that you can see sun noise throughout the day. Even if it's cloudy, you should still see sun noise. And what you saw in Gareth's plot is the same as you can see in the other plot here, is where that was using the mini tuner facility, which was a version 08. There was a noise power meter measurement, and you can see there I did the same as Gareth did. I tracked the dish across the sky into the sun and then back out the other side, and you should see a lovely big peak when you do that. Then if you do that, and if you track it all day long and you see good sun noise, that's great. That means your dish system is working properly. The only other thing then really you can do is test your receive system with a local signal on 2395. And once you've done that, I'm afraid all you can really do is sit back and wait until HAMTV is switched on. So that's the receive system. If you're starting from scratch, definitely go for the one in blue. If you're not, and you've already got the down converter good, there is, as far as I'm aware, there are no commercially available 2.4 down converters. It needs to go down to L band. So another reason why we would recommend you go for the top solution in blue. Right, so once HAMTV is back up, and there's lots of ground stations. The problem with any particular ground station is, as I said, you can only see it for 11 minutes. And so what Phil M0D and Y engineered last time it was on was a server which can combine the UDP outputs from several ground stations. So this is really smart. So what he does is he looks at the incoming packets and can join together the incoming packets and choose the best packet, the least error-free, no, the most error, the ones with least errors, and generate a second stream which comes from the best of the incoming streams. We will be looking for stations to join that network. The server is currently not commissioned because obviously the ISS isn't up. Once the ISS is available again, we will be recommissioning this, and we will then be looking for ground stations to join the network. And if you're running, I'm pretty sure if you're running RIDE and possibly Mini Tuner and Open Tuner, that software is all compatible, so you have to do very little other than just ask Phil for details. And there'll be posts on the forum about this, but we would encourage people, once the ISS is back up and running, we would encourage people to join this network. And the output will appear on the standard streaming page, which is actually listed there and is actually live, but obviously there's no inputs at the moment, so it will be appearing there. So one slide on where we go from here. The next project is Lunar Gateway, of course. 2026, 2027 maybe. And there is an opportunity for getting an amateur platform or capability on that platform. And BATC, Dave, Phil, Graham and I have been actively talking to ARIS, and what we're looking at is a digital communication system which will be much more flexible and be able to transmit data, voice and video. And to that end, Phil, M0, DNY went to the ARIS meeting in Florida last February, and actually showed a concept piece of hardware based around a USRP SDR. And so we are pretty much on top of what's going on there. So if anything is going to happen on Lunar Gateway, it's likely there will be some BATC tape hardware up there, and obviously we will have the chance to to start from scratch with some state of the art hardware. So yeah, just watch this space. Things happen very slowly, but we're hoping it will get there. Okay, so actually I didn't tell Tammy I was going to do this. I'm hoping you will be able to take this. I wanted to just say that a picture is worth 1,000 words, and this is a video.
It is, Noel, because at the moment all we can see is a black box.
Okay, so we're not going to be able to do that.
That's a shame.
That's unfortunate.
Do you want to? Have you played it then? Are you play? Oh no, here it comes. It was just black. We can see it.
Oh, I'll just go back one. Right. So a picture is worth 1,000 words. Now, we during the Tim Peak mission, we did several contacts without HAMTV because either it wasn't ready or it wasn't. It just wasn't practical. But halfway through the exercise, it actually became available, and I can tell you, it just put hairs on the back of your neck when you saw this. It's one thing in a room just listening to a two-way voice contact. It's another thing when actually he appears on the screen behind you, and it really just lifts the whole thing. So I want to show you this video. This is actually taken from Norwich. David and Tammy will recognize this. This is one of our better contacts. It was the Norwich Schools contact in March 2017. And the other interesting thing is that I think this guy's name was Lawrence. I can't remember his call sign, but this was his first. He'd done the classes and got the foundation license, and he received his license a couple of days before this contact.
I think it was Tim actually.
Is it?
I think it's Tim Hare. I think is his name. A young
That's
man.
right. Yeah. Okay. And this was his first ever contact, as I understand it, wasn't it, David?
I think so. We ran just to quickly add a little tiny bit. We did add we ran a special foundation course for youngsters who were interested in coming on this call from various schools, and Tim was one of those students, and he was designated as the lead student for this, wasn't he?
Yeah, and he's got his license 2 days before the contact, or day before the contact, and this is his first ever QSO. Now, for you guys who've been struggling to work the ISS for 20 years, this is actually how you do it. Oh no, it's not. We'll go here.
I can't hear the audio, unfortunately, Noel. So not
Hang
sure
on.
why. Still can't hear it, the audio, but we can see the pictures fine. I don't know why that is.
Oh, okay.
We just didn't know that we were going to take it, but it's nice to see the pictures. I'm sure we can see Tim there. I can't quite read his call. He's wearing a NARC badge, but yeah.
Really badly at the face. Over.
We can hear it now.
We could actually give ourselves some local anaesthetic to stitch it up with the help of some doctors back in a ground control if we need to. Over.
Hi, this is Austin. Are there any protocols or guidance in place if George Clooney comes knocking on the front door as he did in the film Gravity? Over.
Hi, Austin. Well, as far as I'm aware, we're the only 6 human beings in space up here, so if anybody comes knocking on our hatch, I'm not opening it. Over. Tim, it's Kieran M0XTD. We have you on HAMTV. Give us a wave. Here's your next question.
Hi, this is Sophie. What experiment would you like to add to your mission based on the experiences you have
Are you
had?
getting any audio now?
Yes, we are.
Hi, Sophie. I would like to see us doing more of the medical research, investigating some more vaccines and looking into new drug methods as well. I think that's some of the most exciting research we're doing up here. Over.
Hi, this is Max. In what ways does the lack of natural sunlight and fresh air affect you on the ISS? Over.
Hi, Max. I love opening the windows in the cupola when I'm in Node 3 or in the Japanese module. I love the sunshine coming through the windows, and it does make a difference. It does kind of brighten up your day and make you feel better. And you just get used to the fact that we see so many day and night cycles. Over.
Hi, this is Charlotte. How do you get changed in space? Won't your clothes go everywhere? Over.
Hi, Charlotte. They do go everywhere. We have to use bungees. We bungee our clothes down so they don't float off and you don't lose them. Over.
Hi, this is Eden. One of the experiments you are conducting in space is to measure fluid shifts in the body. In what way does this help us back on Earth? Over.
Hi, Eden. That's a great question. Fluid shift really kicks off the whole process of the changes to our body. It's because of the fluid shift we get greater pressure in our head and we start to lose bone density as well. So that triggers all the changes, and it's by changing things in our body that we can learn about our body and we can investigate these things. Over.
Hi, this is Thomas. With the basic design of current spacecraft dating back decades, where do you think the next leap forward in spacecraft technology will occur? Over.
Hi, Thomas. Yes, I mean, we're playing with the basic rules of physics and gravity here and laws of motion. So I think that we're going to see big changes to our spacecraft in terms of our transit to Mars and transit to Moon. But in terms of getting to low Earth orbit, I don't think we're going to see many big changes that we have in current spacecraft design. Over.
Hi, this is Emily. How different was the training compared to the experience of actually launching into space? Over.
I believe the training was so good that it really prepared us for launching into space, and there are very few differences between what we were training for on ground and how we live and work up here in space. Over.
Hi, this is Millie. With improving technology on Earth, are there experiments that you are currently carrying out in space that could one day be repeated on Earth? Over.
Yes, there are loads of experiments up here that we're doing that could be repeated on Earth. I think that it's going to be a long time before we manage to sort of counter gravity for a long period of time on Earth. So we use parabolic flights and drop towers. But the benefit of being up here in low Earth orbit is, of course, we have microgravity continuously. So we can do those experiments for a very long time. But we do repeat the experiments back on Earth, of course, to see the changes, to see what's difference between space and Earth. Over.
Hi, this is Erin. Which materials being developed with the electromagnetic levitator will have the last...
GB.
Right, okay. Can you still hear me, David?
Yes, we can. Thank you.
Okay, so yeah, that gave you a flavour of what HAMTV does for us, and it really did make the whole thing come alive, and it's a great technical challenge anyway. Right, so all of the information I've said today is on the wiki. If you scan that QR code, it will take you to the wiki. Even on YouTube, if you're watching this in 6 months' time, this will take you to the wiki page where you can see a lot more information on everything that we talked about today. We've tried to include absolutely everything in it. And I've had a text while I've been giving this presentation from Graham G3VZV, who's actually watching me in Tampa. And if you want to see his version of this very presentation, he's actually over at the AMSAT symposium in Tampa, and he'll be doing it at 16:45 UK time on the AMSAT web stream. So if you want to see exactly the same presentation, go and watch Graham at 4:45. But I think that concludes everything I've got, David, and hopefully people found it interesting.
Thank you very much, Noel. I'm sure we all found it interesting, and also because I was very involved with that. As you know, our club was very involved with that contact from Norwich. It brought back Yeah, really happy memories for me. It was just great to see young people enthused by technology. It's very hard. I don't know how everybody feels now, but it is quite hard to sometimes impress young people about the wonders of technology when they can do so much with their tablets and their phones. So to show something like that was so amazing, just using our hobby for the communications. It was fantastic. So I will just say well done to you and all of your team, I know, who worked so hard in ARIS to make all this happen, because it really does, I think, inspire generations of young people to go into science and technology in the future. And I really do mean that. So if you have any questions for Noel or any comments, we've got a couple of comments and questions for you. But if you have any, this is the time to do it, because we're coming to the end of our afternoon here. The first question I'm going to read is from Louis in California, CT7BLI. I know of the existence of a station in Portugal which is operational. However, I do not see it as belonging to the ARIS reception network. Any thoughts on that?
Sorry, yeah, what was the first thing he knows about?
Well, he says, I know of the existence of a station in Portugal which is operational. However, I do not see it as belonging to the ARIS reception network. I guess he's not seeing it on the list. Is that?
Yes, there could be, but various people set up HAMTV receiving stations, and it really wasn't publicised that well that the BATC had done the merging server, and so we're hoping to make that more publicised this time round and get everybody to join in.
Okay, thank you, Noel. And also, he's put another part B. Is there any reason for this? Wouldn't it be useful for the station to also send it streaming to this page?
Again, sorry, David, can you repeat?
Yeah, sorry. Louis says, is there any reason for this? And wouldn't it be useful for the station to also send it streaming to this page?
Yes, that absolutely, and everybody can send to it. And we'll be publishing on the BATC forum exactly how you can participate. Yeah, absolutely.
Thank you. We haven't got many other questions for you. Gareth G4XAT, I guess it's an observation. It says lean DVB on an RTL dongle must be bottom line of functionality, he says. But I don't know if you've got experience of that.
No.
Mike,
say really, we need people to tell us a bit more and write up articles on using the software-only solutions.
Yeah, I mean, do this. I've stressed this earlier on with Dave. It is important. We're all members of this club. And although you guys do regularly so much for us, it's really important to share resources, isn't it? And I'm sure there's a lot of talents amongst us. And we can contribute to the success and further success of BATC and, of course, in this case, ARIS as well. Lots of people saying excellent demo of HAMTV. Thank you. I haven't got any other points, I don't think, really, questions. I mean, you've been involved with this project for a long time, Noel. What's your particular highlight? What was the very special moment that you think back of all those contacts that you've helped ARIS with?
Well, interestingly, there was we did a contact in Bristol at a school that had just come out of special measures, and the BBC did a program in their local news on it, and they interviewed a couple of the kids, and they were just so uplifting. The comment the kids were making about what this means and how really it really opened their eyes to the whole world of what's possible out there. And I think that's one level. I think that's the main reason why we do it, is the STEM side of it, as you said earlier. But also from a technical perspective, going down and doing the work at Goonhilly was great fun, and receiving it the first time ever. And actually, the very first contact that we had HAMTV, I think, was at a school in Rickmansworth, and that was a pretty special moment as well. So lots of highlights. There was lots of lowlights, like getting food poisoning in Broadstairs, but it was that was great fun. We've had a real ball doing this. Good.
Well, may it long continue, Noel, to you and to all of your colleagues. Thanks for all you do for the ISS and for the ARIS, and encouraging youngsters as you do. And also thanks to you personally as well for all the work you do for this club as well. Thank you very much indeed, Noel.
Okay. Thank you.
Thank you. Now, before we close this year's CAT convention, here's a few pictures from BATC activities. Good look back at some of the things that we can do in our hobby and in this club. And that almost concludes the British Amateur Television Club CAT24 online convention. We hope you've enjoyed it. If you did not catch all of today's events, then you'll be able to watch it on the BATC YouTube channel in the next few days and weeks and months to come. Now, if this is one of your first experiences of the BATC, then maybe you'd like to consider joining us. Membership currently starts at just £8 a year, which includes lots of benefits, including a magazine, weekly TV nets, events, and a useful projects and parts shop. You can find full details about the club at www.batc.org.uk. But it's goodbye from us and from Tammy M0TC, a vision mixer I think we could show this year for the first and only time. And from me, David G70RP, thanks again for joining us. And we're now going to hand it back to the chairman of the BATC, Martin G4FKK. Bye-bye.
Thank you, David and Tammy. And thank you to everyone who's joined our meeting today. It's been thoroughly absorbing, and even the things I thought I knew a bit about, I've learned something today, and I hope everyone's done that. I'd like to thank individually Dave GHGKQ for the Portsdown update, and very interested in the Muntjac project, and I'm very glad you're keeping Portsdown 5 compatible with Portsdown 4. That's going to be quite helpful. Michael, that was a wonderful presentation. You got an absolutely brilliantly thought through installation over there in Spain. And Martin, G8KOE, that was a tremendous effort. It certainly set the chat boxes whirring as you went through your demonstration, and all sorts of people are thinking of, oh, we could try this, we could try that with Allstar. That would be that's going to be quite an interesting development, I think. And always remember, everyone, 47572 is once you've got your node running, you'll know what I'm talking about. But if you connect to 47572, that's Martin's DATV node, and that could well become, certainly in these early days, a BATC hub for BATC Talkback, etc. And yeah, David and Tammy, thank you for filling almost a complete hour there. Originally, David and Tammy were going to do a few minutes over a lunch break, so that worked out very well. And it's particularly nice for someone like me. I'm into the RF and the electronics side of amateur radio. So my TV camera here is just an old video camera, and I have got one I can wave around at people, and that's it. So I was fascinated by the PTZ cameras, etc. So thank you for that. We could do with a few more talks on that's production and production equipment and lighting and that sort of thing. So if anyone's got any expertise on that, CQTV is waiting to hear from you. Noel, thank you for that. I love that video at the end. I've seen that before, and it really is. It makes you remember why why you're interested in radio in the first place, because it is a bit magic, isn't it? And especially being able to talk to a spaceman, that's very good. And next time my wife says this shack needs tidying up, which it desperately does require, I shall say, oh, well, I'm doing some topographical reassessment. That's a great term. So thanks, David, Michael, Martin, Noel, and for your talks. And thanks to all the viewers for all the questions you put up and for staying with us all day. We've still got 90 odd people on the BATC stream, let alone YouTube and QO100. Thanks to Mike, G0MJW, who's been using up his electricity bill putting this out on QO100 while he's been in QSO with Dave GKQ. And but I'd like to do a huge thank you to David and Tammy, because having seen behind the scenes now, it's not just a couple of cameras lashed up and OBS running on a laptop somewhere. That really is a very, very pretty professional setup you got there, and the production, the mixing, Tammy's work on the buttons there, absolutely superb. So we can't really thank you enough. So that's David, G7URP and Tammy M0TC. That's a great call sign, by the way, Tammy. I wonder how you got a 2-letter one. Right, well, I think that about wraps it up for CAT24 for this year. I'm already looking forward to CAT25. I imagine we're going to do a similar thing, have a live meeting somewhere interesting, probably near Coventry again. And let's hope we can persuade David and Tammy to help us out with a live streaming one as well. So with that, I'll say 73. I don't know if you're going to say a final there, David, but other than that, I'll leave this very useful test card up, because Thursday nights are BATC Thursday evening net nights. Cheerio, everybody. Thanks very much.